So a very good evening everyone. Myself Prateek Mishra and welcome to the Score Booster series of IMS GATE Academy. We will be dealing with environmental engineering for today and tomorrow from 6 p.m. to 9 p.m. My dear students, talking about environmental engineering, it is one of the highest weighted subject with respect to GATE examination if we talk about civil engineering. The approximate weightage of environmental engineering for GATE exam is 10 to 15 marks, one of the highest for civil engineering. If I talk about environmental engineering, the entire environmental engineering has been divided into four major sections. First one is raw water engineering. My dear students, if we want to utilize water for our day-to-day purpose or for some industrial purpose, we need to extract this water from any source. Then we need to treat this water and then only we can utilize this water. The entire engineering of extracting water from the source, treating this water and supplying it to the community is classified as raw water engineering or water supply engineering. This water supply engineering or raw water engineering starts with water demand. In water demand, we actually calculate the amount of water that is required by the community. In order to calculate the amount of water required by the community, we need to know the existing and the upcoming population of the community. So that subtopic with respect to water demand comes to population forecasting. In population forecasting, we actually calculate the expected population after 10, 20 or 15 years, or precisely I would like to say this, we calculate the population of the community over the design period. Once we know the population of the community, we can very easily calculate the amount of water required by this community. Once we know the total amount of water required by the community, we need to identify different sources of water from where this water can be extracted. So the next topic of discussion for water supply engineering is to be sources of water. Once we have taken this water from any source, we have obtained this water from any source. It may be a surface source or a subsurface source. Taking an example, for a surface source, it may be a river, it may be a lake, it may be a pond, and nowadays it may even be an ocean or a sea. So these are the primary example of surface sources. Talking about the subsurface sources of water, the underground water that we extract either by the means of infiltration galleries, infiltration wells. We extract this water from tube wells or open wells or shallow wells or deep wells. All these comprises the example of extraction of groundwater. This groundwater extraction totally depends upon the internal strata of the earth's surface below the ground level. The strata from where this water can be extracted are termed as aquifers, right? So once we have extracted water from the source, directly we cannot consume this water. We need to check whether this water is consumable or not. In order to check whether that water is consumable or not, we need to go for the quality analysis of water or quality checking of water. So the next topic of discussion comes to be the quality or water quality parameters. Using these water quality parameters, we check whether this water can be consumed or not, right? So once we have the existing quality of the water, by analyzing this water through all the water quality parameters, and we know the desired quality of treated water, we have these permissible limits, acceptable limits. So depending upon the existing quality of raw water and the desired quality of the treated water, the degree of treatment is given to this raw water. Next topic of discussion after water quality parameters comes to be treatment of water. In treatment of water, we have different treatment units, and using these different treatment units, we give different degree of treatment to our raw water. Once this water is treated in the water treatment plant, this water is stored in a unit which is known as service reservoirs. My dear students, these overhead tanks that you see in any community are termed as service reservoirs, right? So from the service reservoir, this water is distributed by the means of distribution system in the community. This entire engineering of first calculating the total amount of water required in the community, then checking for the different sources of water from where this water can be extracted, then analyzing this water using different water quality parameters, and then treating this water in our water treatment plant. Finally, storing this water and supplying this water to the community by the means of water distribution system. This entire engineering is termed as raw water engineering. The next part of environmental engineering starts when this water which has been supplied in the community is used up and it is converted into wastewater, right? So the collection of this wastewater, transportation of this wastewater to the sewage treatment plant, then again analyzing this wastewater for checking the degree of treatment to be given. And once this water is analyzed based on the wastewater quality parameters in the sewage treatment plant, we give the treatment to this water. Once this sewage, or I should say wastewater, is treated, this wastewater is finally disposed back to the source. It can be again a river, it can be a lake, it can be a sea or ocean, or it can be directly applied on land. So this entire engineering in which we collect the wastewater, we transport these wastewater by the means of sewers, and then we treat this wastewater in the sewage treatment plant, and depending upon the source in which this water has to be disposed, right, we give the degree of treatment to this wastewater. This entire engineering of collection, transportation, treating and disposing the wastewater is termed as wastewater engineering. Then we have solid waste management, and in solid waste management we precisely talk about the solid waste which is generated in any community. It is specifically named as municipal solid waste management for our syllabus, right? And lastly, we have air pollution. In air pollution, we basically deal about different types of pollutants. Then with respect to the different type of atmosphere, how the plumes are distributed across the atmosphere. Next we talk about in air pollution, that is, if we have any air pollutant, how that air pollutant can be removed from the system. So this entire engineering related to air pollution comes under air pollution engineering, right? So this is our entire syllabus of environmental engineering, and my dear students, I would like to again tell you, it has a weightage of 10 to 15 marks, one of the highest for GATE examination. That's why environmental engineering, being one of the easiest subject and one of the most scoring subject, require a lot of revision, my dear students, across the year, right? So starting with our environmental engineering, our first topic of discussion will be water demand. If I talk about water demand, I have already told you that water demand is the total amount of water required in a community for different usages, right? So if V is the volume of total water required in a community depending upon the different usages, this entire water demand can be classified depending upon its usages, right? So classifying our water demand depending on our usages, first type of water demand is the domestic demand. In the domestic demand, it is the amount of water required for day-to-day purpose, like for kitchen purpose, like for bathing, cooking, etc. Whatever amount of water you require is classified as domestic demand. Next is the industrial demand. As the name says, it's the total amount of water required for different industrial usages. So it comprises of industrial demand. It has a range of 50 to 450 liters per capita per day. The third one is the institutional demand. There are various institutes in a community comprising of any government offices, railway stations, right? So all these institutions, the amount of water required for all these institutions comprises the institutional demand. Next is water for public use. Water for public use is the amount of water required for different road cleaning purpose or gardening of these public gardens. So water for public use is the amount of water required for cleaning of roads and for gardening of these public gardens. So next is your water for public use. Next is your fire demand. As the name says, if any fire outbreak happens in a community, then the amount of water required in the community is termed as fire demand. My dear students, fire demand can be either taken as 1 LPCD approximately, or depending upon the different regions where the fire outbreak happened, we can calculate this fire demand using different empirical formulas. We will going to see the empirical formulas in just a short while, right? Next is thefts and losses. My dear students, when water is supplied into the distribution system, there may be some illegal connections or there may be some leakages. In order to account for all those illegal connections and leakages, the total amount of water loss comes under thefts and losses, and it comprises to 10 to 15% of the total demand of water. As I have already given you the amount of water with respect to the different types of demand, if I just add all these different types of water demand, the total water demand in the community comes in the range of 250 to 350 LPCD, that is liters per capita per day. Now my question is, why I am telling you all this? So this session we will going to proceed considering all the three variety of questions, right? If there is any possibility of the formation of multiple select question, I will be giving you the direct points that you have to take care, right? Talking about the numerical answer type question and the multiple choice question, we will going to discuss it through numerical answer type question. I haven't provided any options in these questions that we will going to see in just a short while, right? So try and solve all these questions and stay with the lecture and stay connected. We will going to revise the entire portion of raw water engineering in just a span of 3 hours using these questions and key points. Okay, so moving on with this, we have discussed about depending upon the different types of usages, the total demand of water has been classified as domestic demand, industrial demand, institutional demand, water for public use, fire demand, and thefts and losses. And the total demand of water in the community comes out in the range of 250 to 350 liters per capita per day. Now, my dear students, my next point of discussion are different types of empirical formulas that are used to calculate the fire demand. Please keep a check on this. So first formula for calculating fire demand is, as per Government of India manual, fire demand is 100 root P. Please take care of the units, and the fire demand that we calculate using this Government of India manual formula is in kilometers. We calculate the total volume, right? Here P is the population of the community in thousands. For example, if I am given with the population as 1 lakh, the value of P that I will going to substitute here will be equal to, corresponding to this population of 1 lakh, the P value that I have to substitute will be 100, because this P is 100,000 and P here is population of the community in thousands. So this is the first formula through which we calculate the fire demand, right? The next formula is known as the Cutsling's formula, and using Cutsling's formula we calculate the fire demand in terms of discharge, right? So according to Cutsling's formula, fire demand Q is equals to 3182 root P, and the fire demand that we calculate is in terms of discharge, that is in liters per minute, right? And P is again the population of the community in thousands. As just now I have explained you, if the population is given as 2 lakh, you have to enter the value of P as 200, because 2 lakh is 200 times thousands. Okay, so P is the population of the community in thousands. The next empirical formula that we use to calculate fire demand is Freeman's formula, that is Q is equals to 1136 P by 10 plus 10, and again the fire demand calculated is in liters per minute. My dear students, in environmental engineering, the most important thing that you have to take care is take care of the units, right? You might have solved the question correctly, but if you have not taken care of the units, the answer that you have calculated may not be correct. Okay, so next empirical formula for calculating fire demand is the Freeman's formula. According to Freeman's formula, fire demand is equals to 1136 P by 10 plus 10, and fire demand calculated is in liters per minute. The next formula for calculating fire demand is National Board of Underwriters method. According to National Board of Underwriters method, my dear students, please take care. If the population of the community is less than 2 lakhs only, if the population of the community is less than 2 lakhs, then fire demand Q is equals to 4637 root P into 1 minus 0.01 root P. Here also the fire demand is calculated in terms of discharge in liters per minute, and P has to be substituted in thousands. So P is again the population of the community in thousands. if the population of the community exceeds 2 lakhs, right? If the population of the community is more than 2 lakhs, then fire demand is equals to 5400 liters per minute for first fire, and it is equal to 9100 to 36400 for second fire. So accordingly, we can substitute the value of National Board of Fire Underwriters method when asked in the question. Please take care whether the population of the community is less than 2 lakhs or more than 2 lakhs. In majority of the question, if you are asked to calculate the fire demand using National Board of Fire Underwriters method, you will be given the population less than 2 lakhs. Okay. The last formula through which, or the last empirical method through which we calculate the fire demand is known as the Buston's formula. According to Buston's formula, fire demand Q is equals to 5663 root P, and again the fire demand calculated is in terms of discharge, that is liters per minute, and P is the population of the community in thousands. So using all these empirical relations, you can calculate the fire demand if asked in the question. The question will be specific to which type of empirical method you have to use for calculating the fire demand. So you need not to worry about that. With respect to GATE examination, if I talk about GATE examination, GATE is very precise and very accurate in forming the GATE question, right? You need not to assume anything from your side, or you need not to take any arbitrary method from your side. It has to be specific and it will be clearly mentioned in your GATE examination. Moving on with this is how we can calculate the fire demand. The next topic of discussion are, once I have calculated the entire requirement of water in a community, there will be some factors that will be affecting this demand. So the next topic of discussion is various factors affecting the water demand. The first factor that affects the water demand is the type of sewerage system. My dear students, it can be directly inferred through your common sense that if your sewerage system is inefficient, you will be require more amount of water in your toilets, obviously. So your domestic demand will going to increase. So if your sewerage system is inefficient, your domestic demand will going to increase. Hence, it affects the domestic demand. Next is the extent of industrialization. As the name says, if more number of industries are present in the community, more amount of water will be required for industrial purposes. Hence, more will be the industrial demand. If your industrial demand increases, more your total demand will also going to increase. So, if extent of industrialization more, your industrial demand will be more. Hence, your total demand will going to increase. Is the size of the city. My dear students, please take care of this factor. That is one of the most favorite factor that has been asked for repetitive number of times, not in GATE but for other exams, but it is expected a statement in a multiple select question for GATE examination in upcoming 1 or 2 years. Probably you may see a question related to this factor in this year itself. When I talk about size of the city, right? When I talk about size of the city, I'm talking about huge cities with huge length of road networks, with huge space of gardens available. If the length of road networks are more, if the space available for garden is more, the amount of water required for public use will be more. So if water required for public use will be more, my dear students, your total demand will going to increase. So if your size of the city is more, water required for public use will be more, hence more will be your total demand, right? Moving on to our next factor, if we talk about the type of gentry, for high class people, it is observed that, it is not a kind of permanent statement, it is just a thumb rule. It is observed that if the class of people is high, the more amount of water is required for the domestic purposes. So if type of gentry is of high class, your domestic demand will increase, hence more will be your total demand. Next is your climatic condition, my dear students. So you can relate it very well. If climatic conditions are warmer, more amount of water required for bathing, etc. purposes, hence more is your domestic demand. So if climatic conditions are warm, more is your domestic demand, hence more will be your total demand. Next is the cost of water and the quality of water. My dear students, please understand this very clearly. When I talk about demand and consumption, they are two different terms. The first term I am writing is consumption. First term I am writing is consumption. The next term that I am writing is demand, right? Let me take a very quick example and a very easy example. For example, if I need to clean this room, right? Sorry, if I need to cool this room. For cooling this room, I required one air condition. That is my actual demand. If one air condition is installed in this room stays cool. But if I provide two air conditioned, right, that is the thing that is I am providing from my side. That is my consumption for my luxury. Actually required is one, what I am providing is two. So whatever actually required is termed as demand, and whatever you are providing is termed as consumption. So please understand the difference between demand and consumption, right? Demand is what which is actually required, and consumption is what actually is provided, correct? So what is required and what is provided is a difference between demand and consumption. So if I talk about cost of water and quality of water, if cost of water is high, obviously your consumption will going to decrease. If you find a water bottle of rupees 75 plus, you may drink it slowly, right? On the other hand, if you find a water bottle of same quality of less than 10 rupees, you may drink it abruptly, right? So that is the basic difference when the cost of water increases. You might be feeling same kind of thirst, but due to higher prices, you may consume less amount of water. But still same amount of water is required for you to remove your thirst, right? So if cost of water is more, your consumption will going to decrease, but the demand remains same. Next is the quality of water. Similarly, if the quality of water is poor, again your consumption will going to reduce, but the demand of water remains as it is. So when I talk about these two factors, cost of water and quality of water, these two factors indirectly affects the water demand, or actually it affects the consumption of water. It does not affect the amount of water required in a community. The last one is the pressure in the distribution system. So if I talk about pressure in the distribution system, my dear students, if the pressure is more will be the leakages, hence more will be the total demand. So if the pressure in the distribution system is more will be the leakages, hence more will be the total demand. So these are the different factors that I have listed that affects the water demand. You may take care of all these factors. A statement can be formed using these factors, and that statement can be a statement of a multiple select question. So whatever key points we will be discussing here, you should take care of that, keeping in mind that any statement can be framed for multiple select question using these key points, right? Moving on with this. When we talk about water demand, there are fluctuation in water demand. Obviously, if we take a round clock, in this round clock for one day, you might not be consuming same amount of water for every hour, right? There will be some hours where you might be consuming more amount of water. There will be hours where you might not be consuming any amount of water, right? So taking this into consideration, we have defined the fluctuation in water demand. So fluctuation in water demand is the maximum amount or the maximum amount of water that can be used within an hour, within a day, within a week, within a month. That is termed as the maximum demand depending upon the duration. So the ratio of maximum demand to the average demand can be calculated using Goodrich's equation. Goodrich's equation gives us the percentage ratio of maximum demand to the average demand. And according to Goodrich's equation, the percentage ratio of maximum demand to average demand can be calculated as 180 into t raised to the power minus 0.1. Okay. So this is the Goodrich's equation, and using this Goodrich's equation, you can very well calculate the percentage ratio of maximum demand to average demand. My dear students, till now, we haven't seen any question from this equation, but it is expected that you will going to see a question of 1 mark in GATE examination in upcoming 1 or 2 years, right? If you just analyze the pattern of GATE examination over the last 4 or 5 years, Earlier, there are fixed domain from where questions are asked, but from last 4 or 5 years, my dear students, this domain has shifted a bit, right? So you have to read whatever there's in the syllabus. Please do not consider important points, or what I should say, important areas. You may focus more, but please try and cover the entire syllabus that is prescribed to you for GATE examination. Next is, I have drawn a table depending upon the duration and the fluctuation in the water demand. If I talk about the hourly fluctuation, talking as 2.7, I am talking as maximum hourly demand, maximum hourly demand to the average hourly demand, to the average hourly demand, and it is given to me as 2.7, right? So accordingly, you can use all these fluctuations using these tables, and you can calculate the maximum hourly demand to average hourly demand, or whatever is required for the question, right? So for daily hourly duration, the fluctuation is 2.7. For daily duration, the fluctuation is 1.8, and for weekly duration, it is 1.48. For monthly, it is 1.28, and for yearly, it is 1, right? Moving on with this. Next, first we need to calculate the population of the community. Then only we can calculate the amount of water required by the population of the community, correct? In order to calculate the population of the community, again we have different methods for calculating, right? If we talk about the increase of population or the change of population in a community, it basically depends upon the 4 factors. First is the number of births happening in any community. The population of any community, the change in population of any community depends upon 4 factors. First one is the number of births happening in that particular community. Second one is the number of deaths happening in that particular community. The third one is the outward migration happening in that particular community. And fourth one is the inward migration happening into that particular community. If for suppose in any city there are less chances of jobs, obviously the students residing there or the population of that particular city will move outwards if they are mentally towards job seeking kind of community, right? On the other hand, if you take an example of a city where there are more chances of job, obviously more people will join that particular city and inward migration will going to happen, and you will see the increase in population of that particular community. So if I talk about the change in population of the particular community, the change in population of the particular community depends upon the 4 factors. First one is the number of births happening. Second one is the number of deaths happening. The third one is the outward migration happening in that particular community. And fourth one is the inward migration happening in that particular community, right? Next is, if we try to calculate the population of the particular community, we have different empirical methods. So the first method for calculating the population of the community is known as arithmetic increase method. And using arithmetic increase method, we can calculate the population of the community as Pn is equals to P naught plus n into x bar, where P naught is the last known population of the community from where you have to calculate the future population. So P naught, say for this day, from this day, I have to calculate the population of the community after 50 years, right? So the population of the community at this very particular day will be my P naught. Next is N. N is the number of decades after which you have to calculate the population of the community. X bar is the increase in population, right? So Pn is equals to P naught plus Nx bar. So using this relation, you can very easily calculate the population of the community using arithmetic increase method. The next method for calculating population of the community is using geometric increase method. Again, the population of the community at this very particular day will be my P naught. R is the percentage increase in population, right? R is the percentage increase in population, and N is the number of decades after which you need to calculate the population of the community. So using Pn is equals to P naught plus 1 plus R into N, Pn is equals to P naught into 1 plus R raised to the power n. Using this relation, you can very well calculate the population of the community after n number of decades, right? The third type of method for which the population can be forecasted is incremental increase method, and using incremental increase method, Pn is equals to P naught plus Nx bar plus n into n plus 1 into y bar. Again, P naught is the last known population, x bar is my increase in population, it is my average increase in population, and y bar is incremental increase in population, that is increase over increase in population, that is my y bar. So Pn is equals to P naught plus Nx bar plus n into n plus 1 into y bar. So using these three empirical methods, we can forecast the population of the community over any number of decades, right? If I talk about all these methods, the least value of population forecasted is obtained using through arithmetic increase method. Arithmetic increase method gives us the least value of population forecasted. If I talk about the highest value of population forecasted, that is obtained using geometric increase method. Geometric increase method gives us the highest amount of population forecasted. On the other hand, if we talk about the incremental increase method, it gives us the value of population forecasted between arithmetic increase method and geometric increase method, right? So you can also relate it as, if we need to calculate the population of young growing city, increase method. If you need to calculate the population of a city which is approaching towards saturation or saturation population, you can use the arithmetic method. That is, if you need to calculate the population of an old city, use arithmetic increase method. If you need to calculate the population of a young city, you can go for geometric increase method, and in between of these two cities, you can use incremental increase method, right? So all these three methods can be used to forecast population of a community. Moving on with this is the first question that we are reading. Please read the question. Please read the question. Okay, please read the question. The question says that present population of the community is 30,000. The present population of the community is 30,000. My dear students, this type of question where two concepts are required, right? Where two concepts are required, that question can be of 2 marks. Okay, so whenever two concepts are required or two formulas are used, question will be of 2 marks. If a single concept or single formula is used, that particular question will be of 1 mark. Sorry, my dear students, I was not able to see this chat box. It is currently open. So Chandru, very good evening. Good evening everyone. A very good evening everyone. Hopefully you are getting the concepts correctly, right? So just carry on with this. If we talk about, my dear students, GATE examination, right? GATE is Graduate Aptitude Test for Engineering. Please focus on the word aptitude. Here in GATE examination, you may not expect a question that is asked by just mugging a few things and then just vomiting in the examination, correct? You need to go for the logical reasoning. If you have a question in GATE examination, it will be based on some technical logical reasoning. So while preparing for GATE examination, please take care of this thing that you need to practice more number of problems for developing this technical aptitude, correct? Now seeing this question back again, present population of the community is 30,000 with an average water consumption of 4,500 meter cube per day. Okay, please tell me, what do you understand by this? If we have a population of 30,000 and this population is consuming 4,500 meter cube per day of water, so I can write it as my P naught is 30,000, and this 30,000 population is consuming 4,500 4,500 meter cube per day of water, right? So from here, I can very well calculate how much amount of water can be consumed by one person. So using this, I can calculate the water consumption by water consumed by water consumed by water consumed by one person, or water consumed by one person will be equal to water consumed by one person water consumed by one person will be equal to total water consumed, that is 4,500 meter cube per day, divided by the population of the community, that is 30,000. So this is my water consumed. This is my water consumed by one person, right? So please take care. This is the water consumed by one person. Now the question further says that the existing water treatment plant has the design capacity of treating 6,000 meter cube per day of water. Right now, 4,500 meter cube of water is being consumed by the population of 30,000. Correct? Now this water treatment plant has a design capacity of 6,000. Correct? Move on with this. Expected that the population will increase up to 45,000 during the next 20 years, the number of years from now when the plant will reach its design capacity, right? Now let me make this question very simple to you. Currently, you are given with the population of the community, and corresponding to this population, you are given with the water consumed by this population, right? You are asked to calculate the population for which the water consumed will be 6,000 meter cube per day, and in how much time this population will rise from 30,000 to that value. This duration you need to calculate, correct? So we have the water consumed by one person. So if I need to calculate the population corresponding to which the total water consumption will be 6,000, that can be calculated simply as, so population, or I should say design population will be equal to water consumed, or design capacity of the water treatment plant, divided by the per capita water consumption, that is 6,000 divided by 4,500 divided by 30,000. Just give me a quick calculation, my dear students. How much value you will get? Just give me a quick calculation. So this is 6,000 into 30,000 divided by 4,500. Just give me a quick calculation. How much we will get? Just give me a quick calculation how much we will get as design population. So this is 4 times, this is 3 times, and this is 1, 2, 3, 4, right? So the design population comes out to be my design population comes out to be 40,000. My design population comes out to be 40,000. So this is my design population. Now in the question it is asked that in how much time the population will increase from 30,000 to 40,000. One more additional information is given to you in the question, and that is that the population is increasing through geometric rate of population growth. That is, we need to use the geometric increase method for calculating the amount of population, for the number of years in which the population rise from 30,000 to 40,000, right? So if I need to calculate this number of years, I can use Pn is equals to P naught into 1 plus R raised to the power n. So here we have to calculate the N, and we don't know anything about the rate of growth of population. So these two parameters are unknown. We know about P naught. So P naught is 30,000. P naught is 30,000 and Pn is 40,000. Pn is 40,000, right? So if we know the value of R, we can very well calculate the value of N. Okay. So for calculating the value of R, one more data is given to us. One more data is given to us in the question, and it is that, let me just clean up few things, that in the next 20 years, the population of the community will rise up to 45,000. Correct. So using this data, we can very well calculate the value of R. Just understand how we calculate this. So we have P2 is equals to P naught into 1 plus R raised to the power 2. Because in 20 years, the population will grow up to 45,000. So if the number of years are 20 years, the value of N will be equal to 2, right? So P2 is given as 45,000. P2 is given as 45,000. P naught is 30,000. And R we need to calculate raised to the power 2, right? So this will be 45,000 divided by 30,000 is equals to 1 plus R the whole square. Just give me the quick calculation and calculate and tell me the value of R. Thank you, Ankit sir. Thank you, Varsha. Please give me the quick calculation and tell me the value of R. So the value of R will be equal to 0.2247. So this is my value of R. That is 0.2247. Just substitute this value of R in this formula and you will get the number of decades. So I'm just substituting this. So here Pn I have, so Pn is 40,000, P naught is 30,000, R I have, R is 0.2247 and N we need to calculate, right? So take this 30,000 here, you will be having 4 by 3. So this is 4 by 3 is equals to 1.2247 raised to the power n. Now, my dear students, most of the students face difficulty in solving such kind of expressions, right? In solving such kind of expressions, students usually face difficulty. This can be very easily handled if you take a log on the either side. So just take a log on either side. So natural log of 4 by 3 will be equal to natural log of 1.2247 raised to the power n, right? Log a raised to the power b will be equal to b log a. So here we have natural log of 4 by 3 will be equal to n natural log of 1.2247. Just get me the value of n. Tell me the value of n. Good evening, Rahul. Good evening. Good evening, Kiran. Just get me the value of n. Get me the value of n. So n is the number of decades in which the population will reach from 30,000 to 40,000, right? So correct, Prashant, it is 1.419. So this is the decades, right? This is the decades. So if we need to calculate the number of years, it will be n is equals to 14.2 years. I have just rounded off this, right? I have just rounded off. So number of decades or the number of years in which the population of the community will reach to its designed population will be 14.2 years, right? Hopefully you have understood the solution. Any doubt in this? Getting this? Please give us a thumbs up if you are getting this. If you are getting this, please give a thumbs up if you are getting this. Any doubt in this? Shall we move on? Shall we move on with this? Okay. So first, we have calculated the amount of water required in the community, and using that, we have calculated the population of the community. Using the population of the community, we have calculated the total amount of water required in the community, and that corresponds to the water demand. Once we know the water required in the community, the next thing we need to do is to identify all the sources from where this water can be extracted. So the next topic of discussion, my dear students, is sources of water. If we talk about sources of water, majorly there are two types of sources: surface sources and subsurface sources, correct? If I talk about surface source, it can be a river, lake, pond, ocean, sea, as I've already told you. If I talk about subsurface sources, it can be springs or aquifers, correct? There may be some artificial constructions that can be made in order to extract this underground water. These artificial constructions include either infiltration galleries, infiltration wells, open wells, tube wells. So all these artificial constructions can be used to extract this underground water, right? Now if we talk about extracting this underground water, we as an engineer, what we need to think is, we need to extract this underground water feasibly, right? Taking economics in our mind as well. So first thing that we need to analyze is whether sufficient amount of water is stored inside the ground surface or not. The next thing is, this underground water which is stored there, it can be extracted feasibly or not, right? So if I talk about extraction of groundwater, it depends upon two parameters, right? If I talk about extraction of groundwater, thank you Amit, thank you. If I talk about extraction of groundwater, it depends upon two parameters. The first parameter is the porosity, right? Porosity is a parameter which tells us about the amount of voids present in the soil medium. And in this soil medium only, this water is stored inside, correct? So if more amount of water is stored inside, obviously more voids has to be present in the soil medium. And if we need to analyze the soil medium, depending upon the voids present, the parameter used here will be the porosity. So porosity is the parameter which tells us about the amount of space that is available, right? So if we talk about the porosity, porosity is the ratio of volume of voids to the total volume of the medium. Volume of voids will going to tell us about the space that is available with us in which this water is stored. If we talk about the total volume of the soil medium, the ratio of these two will going to give us the porosity of the soil medium. So porosity of the soil medium, my dear student, will going to tell us how much amount of water that can be stored inside the soil medium, correct? Next thing is, the next parameter is the permeability. Once we know the storage capacity of the water in the soil medium, the next thing we need to analyze is how easily this water can be extracted from the soil medium. Once this water is extracted from the soil medium, obviously, my dear students, it will going to face resistance while moving upwards, and this resistance will be through the soil medium surrounding this water, my dear students. So the frictional resistance offered over this water which is being extracted from the soil medium is determined using next parameter, which is known as permeability. So permeability is the parameter which tells us about the rate of flow per unit area per unit hydraulic gradient. If I talk about rate of flow, it is the discharge. So permeability K is defined as the rate of flow Q per unit area per unit hydraulic gradient. So if I say for 1 meter square area, for I is equals to 1, hydraulic gradient. Just wait a minute, I will explain you what do you mean by hydraulic gradient. If I is 1 and area is 1, how much amount of water is extracted, that is termed as the permeability of the soil medium. My dear students, when the water flows from one end to the other end, the frictional resistance, due to the frictional resistance offered over this water will going to face some head loss. So this head loss per unit length of flow is defined as the hydraulic gradient I. So this hydraulic gradient I is defined as the head loss HL per unit length of flow. So the length through which this water is flowing is known as the length of flow, and the amount of energy this water is losing while flowing from one end to the another is known as the head loss. Thank you Rakesh, thank you ma'am. Moving on with this. So using these two parameters, The first parameter, porosity, will going to tell us how much amount of water is stored inside the soil medium. The second parameter, my dear students, permeability, will going to tell us how easily this water can be extracted from the soil medium. Okay, so using these two parameters, we can tell us whether this underground water can be extracted feasibly or not. If we talk about the important formulas, so using Darcy's law, we have calculated the average velocity of flow, and average velocity of flow is equals to k into I. My dear students, this is not the velocity of flow. This is the average velocity of flow, and through this velocity water will not going to travel. The entire explanation we had when we discussed this Darcy's law and the entire derivation in our classroom itself, right? So average velocity of flow, V is equals to K into I, and discharge, as you know that, it is A into V. So A into V, this K into I is nothing but the average velocity of flow. So K into I, this is V, and multiplied by the area, this will going to give us the discharge, and this discharge is equals to K into I into A. Just wait a minute. Okay. So hopefully, my dear students, you are understanding. Rakesh, you are understanding well, right? Moving on with this, we are talking about the important formulas that will be used for solving our question. The first is, using Darcy's law, we have calculated the average velocity of flow. Next is the discharge. Q is equals to K into I. Thank you, Thiru sir. Thank you. Next is the seepage velocity. My dear students, seepage velocity is the actual velocity through which the water will flow from one end to the another, right? Average velocity of flow is not the velocity through which water is flowing. This seepage velocity is the actual velocity of flow through which water is flowing from one end to the other end. And the seepage velocity of flow is equals to average velocity divided by porosity into degree of saturation. This N is the porosity of the medium and S is the degree of saturation. So seepage velocity of flow, Vs is equals to average velocity divided by porosity into degree of saturation. Okay, so hope you have understood this. Moving on to our question. Question says that two wells are situated at a distance of 2 kilometers. Two wells are situated at a distance of 2 kilometers from each other in the soil medium, indicating the head difference of 2.5 meters in the direction of flow. If the porosity and permeability of the soil medium is 25% and 50 meter per day respectively, compute the time taken by the inner tracer to pass from one well to the another. Okay, now understand this question very well. My dear students, we were talking about these smart methods, easy tricks and all those things when we watch all these lectures, right? Any method that can be evolved by understanding a question properly is a smart method. A smart method can only be developed by our aspirants if he understand or if she understands the question properly, right? Before attempting any question, please read the question properly at least twice or thrice, and please be clear what is actually asked in the question. If you are clear what is asked in the question, you will definitely get the answer in just first attempt. So if you are taking time in reading a question, that is not a problem. But if you are quickly reading the problem just to solve it, that is the actual problem, my dear student. So please take care. If you are appearing for GATE examination, please read the question properly. Please read it properly, right? Now the question says that two wells are situated 2 kilometers apart. So let me draw those two wells which are situated 2 kilometers apart. So this is my first well. This is my first well. And this is my second well. And these two wells are situated 2 kilometers apart. These two wells are situated 2 kilometers apart. So distance between these two wells is 2 kilometers. This is 2 kilometers. What the question says is, two wells are situated at a distance of 2 kilometers from each other in the soil medium, indicating the head difference of 2.5 meter in the direction of flow. The water is flowing from one well to the other like this. The water is flowing from one well to the other like this, indicating the head difference. Let me just draw. This is the head of water in the first well and this is the head of water in the second well. So this head difference of 2.5 meter, this head difference of 2.5 meter, so this will be my head loss that is occurring when the water is flowing from one well to the other. Okay, moving on with the question, it says that if the porosity and the permeability, porosity is given as 25% and permeability is given as 50 meter per day respectively, then compute the time taken by the inert tracer. Now understand this, inert tracer is nothing but a dye or something that does not changes its color. So if you enter inert tracer and one well, if you just enter or just spill an inert tracer in one well, the question is asking in how much time this inert tracer will reach to the another well, right? For this we need to know the velocity of flow, and I have already told you, my dear students, the actual velocity of flow is the seepage velocity. If you know the seepage velocity, you can very well calculate the time in which the inert tracer will reach from one well to the another, because you already know the distance between both the wells. Okay, so in order to calculate the seepage velocity, we know that seepage velocity Vs is equals to average velocity of flow divided by porosity multiplied by degree of saturation. Is this okay? Now the degree of saturation is already 1 because the water is already flowing from one well to the another. Talking about the average velocity of flow, this average velocity of flow is K into I divided by the porosity. Now this I hydraulic gradient can be very easily calculated as this I hydraulic gradient is nothing but the head loss divided by the length of flow. So the head loss is 2.5 meter, it is already mentioned. So head loss is 2.5 meter and the length of flow is 2 kilometers. Keep it in meters. So it will be 2000 meters. So this will be my head loss. Okay. So sorry, length of flow. So hydraulic gradient is nothing but 2.5 divided by 2000. Just give me the quick value of this hydraulic gradient, or we can directly substitute it here itself, right? So just substitute this hydraulic gradient for calculating the seepage velocity. So I am just substituting this value of hydraulic gradient directly in this formula. So I will be getting as K is given as 50 meter per day. I am just writing the units beside the parameter. I is unitless and it is 2.5 divided by 2000. It is unitless. Next is porosity. Porosity is again unitless and porosity is, I guess, given as 25%. So it can be written as 0.25. It can be written as 0.25. So just get me the value of seepage velocity in meter per day. Please calculate and tell me the value of seepage velocity in meter per day. Please calculate and tell me the value of seepage velocity in meter per day. Please get me the value of seepage velocity in meter per day. So my seepage velocity will be 0.25 meter per day, right? So my seepage velocity will be 0.25 meter per day. I have the seepage velocity. This is the velocity through which water is moving from one well to the another, right? I have the total distance between the two wells, that is 2 kilometers. So very easily I can calculate the time required by the inert tracer from moving from one well to the another. So velocity I have, distance I have, I can simply calculate the amount of time that inert tracer will take from moving from one well to the another. So time taken by inert tracer, time taken by inert tracer, time taken by inert tracer will be distance, that is 2000 meters, divided by velocity, that is 0.25 meter per day. So in days I will get the time, and just get me the quick time in which the inert tracer will reach from one well to the another. It is 2000 divided by 0.25 and it comes out somewhere around 8000 days. So this is 8000 days, right? My dear students, most of the students, the major problem that they face is they do not believe in the solutions they are doing. No doubt they are attempting the question correctly. No doubt they are understanding the question correctly. But the kind of answers they get, sometimes they doubt their actual calculation. So my dear students, if you are applying the concepts correctly, never ever doubt your calculations, right? So 8,000 days, in 8,000 days, your inner tracer will reach from well 1 to well 2 while moving through seepage velocity, right? So hopefully you have understood this. Correct, Rakesh, correct. You are getting the correct answer. Okay. Okay. Moving on with this. The next concept is, if you allow any water to flow under gravity, right? If for suppose I have a soil medium like this, and in this soil medium, this water is flowing under gravity. This water is flowing under gravity, right? So if I closely observe this soil medium will be like this. This soil medium will be like this. And between this soil medium, there will be voids present. Between this soil medium, say this is my soil medium, this is my soil medium, and between this soil medium, there will be voids present in it, right? So between these voids, my water will be filled like this. This is my water filled between the voids, correct? If the water is flowing under gravity, सर इनर ट्रेसर क्या होता है, प्लीज हिंदी में समझा दीजिए मेरे भाई. इनर ट्रेसर होता है डाई, करेक्ट? कोई भी टाइप की इंक जो कि ट्रेस करी जा सके, जो वाटर से डिफरेंट कलर की होती है. अभी क्लियर? अभी क्लियर राकेश? प्लीज टेल मी यस और नो. अभी क्लियर? किसी भी टाइप की डाई जो वाटर से डिफरेंट कलर की होती है और कितना भी उसको डिसॉल्व कर लो, स्टिल इट कैन बी ट्रेस्ड इजीली, राइट? तो उसको हम इनर ट्रेसर बोलते हैं. ओके, चलो मूविंग ऑन विद दिस. So I am talking about a soil medium under which water is flowing under gravity. I have drawn a soil medium, and in the voids of the soil medium, this is the water filled, correct? If the water is flowing under gravity, not all the water is leaving the system. Please understand this. Not all the water is leaving the system. Some amount of water will be absorbed. Some amount of water will be absorbed over the surface of the soil medium. Some amount of water will be absorbed over the surface of the soil medium due to the adhesive forces between the soil medium and this water molecule. Okay, so when the water is flowing under gravity, not all the water will going to leave the system. Some amount of water will going to restrict over the surface of the soil medium. Now, in order to decide how much amount of water is flowing out under gravity and how much amount of water is retained against gravity, we have defined two parameters. Please understand this carefully. We are talking about flow under gravity, right? This flow of water is happening inside the soil medium and under the action of gravity. No artificial forces are applied. Only force that are acting is the weight of gravity. Is this okay? So under the action of gravity, how much amount of water is leaving into the system and how much amount of water is retained against gravity, in order to define that, we have defined two parameters. First one is known as the specific yield. A specific yield is defined as the ratio of volume of water drained divided by the total volume of medium drained. Volume of water drained means the total amount of water leaving the system, right? So total amount of water leaving the system is defined as volume of water drained. So specific yield gamma S is defined as the volume of water drained. It is defined as the volume of water drained. It is defined as the volume of water drained to the total volume of the medium drained. Next is specific retention. Specific retention is defined as the amount of water retained against gravity about divided by the total amount of medium drained, right? So we have two parameters, specific yield and specific retention. Specific yield is the volume of water drained divided by the total volume of the medium. The next is the specific retention, which tells us about the volume of water retained against gravity divided by the total volume of medium drained. So this gamma S plus gamma R is equals to N into S. Again, N is the porosity of the soil medium. This N is the porosity of the soil medium, and S is the degree of saturation. My dear student, one of the most important relation, because a very easy and quick questions can be framed using this relation. So always please keep this relation in your mind while solving any question, right? So please keep these relation in your mind. Please mark it as most important, because very easy and definite questions can be framed through this relation. Not only environmental engineering, geotechnical engineering, hydrology, irrigation, questions can be framed using this relation. You will going to see this relation in all the three subjects. And my dear students, a very easy question can be framed. The question that we will going to see is using this same relation. The question says that the water table of an aquifer drops by 150 centimeter. Correct? So what I would like to say is, for suppose this is my ground level. This is my ground level. Earlier, the water table was here. Earlier, the water table was here. This water table dropped by 150 centimeter. This water table dropped by 150 centimeter. Now the new position of my water table is this. And this drop is 150 centimeter. This drop of water table is 150 centimeter. The question is further saying over an area of 50 hectares. Over an area of 50 hectares, when the water is moving under the action of gravity, the water level drops by 150 centimeter. Again, the porosity and specific retention of the aquifer medium are 25% and 5% respectively. Let it be just for a while. Calculate the change in groundwater storage. Calculate the change in groundwater storage. Please mark my word, whenever such kind of expression comes in a question, the change in groundwater storage always accounts for the amount of water that is drained out of the system. The change in groundwater storage is nothing but the volume of water that is drained out of the system. And we have seen that the volume of water drained can be calculated using specific yield. Correct? So if we know the specific yield, we can calculate the volume of water drained by knowing the total volume of medium drained. Total volume of medium drained we know because we have the area and we have the change in, we have this change in the level of water. Sorry. We have the change in water level. We have the area. So we very well know this is the volume that we need to calculate. This is the volume that we need to calculate over which this change has happened, where the water level has dropped by 150 centimeter. Okay, so volume we know. We need to calculate VD. But gamma S we don't know. If gamma S is not there, we are given with the specific retention and porosity. And if we know the specific retention and porosity, this is my porosity and this is my specific retention. If I know the specific retention and porosity, I can very easily calculate the specific yield. Okay, so let me just rub all this and solve this properly. So what I need to calculate? I need to calculate VD. In order to calculate VD, I need to know a specific yield. In order to calculate specific yield, I know a relation, that is gamma S plus gamma R is equals to eta into S. Sorry, N into S, where N is the porosity of the medium and S is the degree of saturation. As the water is draining out, the degree of saturation of the soil medium is 1. Porosity is given as 25% and specific retention is given as 5%. So from here I can calculate gamma S plus 0.05 is equals to 0.25. Give me the value of specific yield. My dear students, quickly give me the value of specific yield. Tell me the value of specific yield. What is the value of specific yield? Gamma S. Tell me the value of specific yield quickly. So it's a quick calculation. So gamma S gamma S is equals to 0.2. So this is my gamma S, and gamma S is 0.2. Now, we know that gamma S is equals to volume of water drained to the total volume of medium drained, right? So total volume of medium drained can be calculated as this. Gamma S can be written as 0.2. VD we need to calculate, and total volume of medium drained is 50 hectares multiplied by 150 centimeters, right? So I'll just write it as 50 multiplied by 1.5. I have converted this centimeter into meters. So divide by 1000. So I have divided 150 by 100. So that will going to give me this depth in meters. So this is the unit that I will be getting in hectare meter, correct? And in the question, the answer is asked in hectare meter only. This gamma S is unitless. So just multiply this 0.2 into 50 into 1.5 and you can directly get the volume of water drained. So VD is 0.2 into 50 into 1.5. Get me the value of VD, volume of water drained. Get me the value of VD, volume of water drained. Thank you, sir. VD is 15. Tell me the value of VD. Tell me the value of VD. Tell me the value of VD. It is 15 hectare meter, right? So Varsha, correct. VD is 15 hectare meter. So my final answer is 15 hectare meter. 15 hectare meter. So VD is 15 hectare meter. Thank you. Good. Good. Thiru. Good. Hitesh. Good. Good. Prashant. Good. Kiran. Good. Rakesh. Good. So this is one of the most expected question, right? You should always remember. Thank you, Vipin sir. Thank you so much. This is the most expected question because this question can be expected not only from environmental engineering. This question can be framed from geotechnical engineering. This question can be framed from hydrology irrigation also. So you need to remember a specific yield plus a specific retention is equals to porosity into degree of saturation. So hopefully this is clear to you. This is clear to you. Shall we move on? Say, give a like button. Please give a like button. If you are, sorry, not a like button, just give me a thumbs up. If we move on, we are moving to the third very important chapter of environmental engineering from where majority of the questions are asked, right? So shall we move on? Shall we begin, please? Okay, so moving on with this, the first thing that we learnt is what is or how to calculate the water demand. The next thing we calculated or learnt is how this water demand can be fulfilled by extracting this water from different sources. After this, once we have this water extracted from different sources, the next thing we need to do is to analyze this water using different water quality parameters. My dear students, these water quality parameters are divided into three categories. First one is the physical water quality parameter. Okay, thank you, Rakesh. Thank you. Moving on with this physical water quality parameter. So any water quality parameter that can be felt or sensed by any of our senses are classified as physical water quality parameter. Physical water quality parameter comprises of suspended solids. Suspended solids can be seen, hence classified as physical water quality parameter. Next is the turbidity. Hence the turbidity can be seen, hence classified as physical water quality parameter. Next is the color. Again, color can be seen, hence classified as physical water quality parameter. Taste and odor can be felt or can be sensed, hence classified as physical water quality parameter. Temperature can be sensed, hence classified as physical water quality parameter. My dear students, please take care of this thing. Suspended solid is a physical water quality parameter. On the other hand, dissolved solid is a chemical water quality parameter. Any physical water quality parameter will not going to affect the chemical quality of water. It will only going to change its appearance. It will only going to change its temperature. It will only going to change its odor, its color. It will never going to change its chemical quality. Is this clear to you? Now talking about this, when we extract water from two different sources, for suppose from one source is our river and the next source is our infiltration gallery or anything which is underground, right? So one is the surface source, the other one is the subsurface source. When we extract water from the surface source like rivers, lakes and ponds, you can find huge amount of suspended solids present, right? So water extracted from the surface source need to be given treatment corresponding to the suspended solids. On the other hand, if you extract this water from the underground source, this water which is penetrating underground during this infiltration, this water goes through the process of natural purification, due to which all the suspended solids are removed from the system, and this water which is underground only contains the dissolved solids, correct? So any water which is extracted from the surface source needs treatment corresponding to suspended solids and dissolved solids, but the water which is extracted from underground needs treatment only corresponding to dissolved solids, because under the purification or under the natural purification process during infiltration, all the suspended solids will be removed from the system. Next is the chemical quality parameters. If we talk about the chemical quality parameters, it starts from dissolved solids, alkalinity, pH, hardness, nitrogen, chloride and fluoride content, dissolved gases and minerals. All these water quality parameters, all these chemical water quality parameters affects the chemical quality of water. Then last one is the biological water quality parameters. In biological water quality parameters, we need to check what are the disease causing microorganisms present in the medium. So using all these water quality parameters, we analyze the quality of water. So if anybody asks you how to analyze the quality of water, you will going to say that we will going to analyze the quality of water using water quality parameters. And these water quality parameters are of three types: physical water quality parameter, chemical and biological water quality parameter. Moving on with this, so the first one is the physical water quality parameters. My dear students, I have prepared a precise table from which, again I am telling you, from which a question from multiple select type can be formed, correct? In multiple select question, more than one options can be correct. Is this okay? So moving on with this, so we have physical water quality parameter. The first physical water quality parameter is suspended solids, and it is determined using gravimetric technique. Any technique in which we measure the weight of the unknown parameter is known as the gravimetric technique. The permissible limit of suspended solid is 30 mg per liter according to National Environment Protection Act. Moving on, next is the turbidity. Turbidity can be defined as the amount of light absorbed or scattered while passing through water is termed as the turbidity of water. This turbidity will going to occur through the suspended solids. When suspended solids are present in water, when the light enters from one end, this light gets scattered or absorbed by getting attached to the suspended solids or by getting in contact with the suspended solids. When a light entering in this water medium comes in contact with the suspended solid, this light either gets scattered or absorbed. This scattering or absorption phenomena is termed as Tyndall effect, and the amount by which this light is either scattered or absorbed is termed as its turbidity, right? So turbidity is basically caused by suspended solids, but it is not directly related with suspended solid, that we will going to see in just a quick while. So this turbidity can be measured by color matching technique, and color can be by Fuller's earth or formazine. If the color is developed by Fuller's earth, the unit will be STU, silica turbidity unit, and if the color is developed using formazine, the unit will be NTU or FTU. NTU is Nephlo turbidity unit and FTU is formazine turbidity unit. The permissible limit of turbidity is 1 NTU. All these permissible limits are directly copied from Central Pollution Control Board website, which is the most authentic website with respect to these permissible limits. The next type of physical water quality parameter is color. Again, the color is determined using color matching technique, and the equipment in which this color is determined is known as tintometer. In this tintometer, the color is developed using platinum in the form of chloroplatinate ion. Please take care of all these terms because these terms can be directly used for forming a multiple select question. Next is your taste and taste and odor can be easily measured using dilution, and the equipment used is known as the osmoscope. The permissible limit of taste and odor is 1 TON, and 1 TON means one threshold odor number, whereas for permissible limit of color it is 5 TCU, and 5 TCU means true color unit or Hazen's unit. The last physical water quality parameter is the temperature, and it is obvious measured using thermometer. The permissible limit of temperature lies in the range of 10 to 25 degrees Celsius. So this is the quick briefing about all these physical water quality parameters. Now taking the question says that following observations are being made on a raw water sample for determining the solids in it. When we have discussed to determine the solids, we have discussed in two steps. First is keeping it in oven and determine total quantity of solids. The next one is keeping it in a muffle furnace and determining the fixed quantity of solids. Because when we keep the solids in the muffle furnace, all the organic fraction or the volatile solids will going to vaporize in the medium, right? So here is the data given. A crucible was dried to a constant mass of 58.68. Let me just mark it as W1, and this W1 is the empty weight of the crucible. The volume of the sample is 50 ml. The volume of the sample is 50 ml. Well mixed was taken in the crucible. This 50 ml volume of sample is placed in a crucible and it is kept in the oven. Let me just draw this. So I have taken this water sample. I have taken this 50 ml water sample. I have taken this 50 ml water sample and I have placed it in an oven. I have placed it in an oven. I have placed it in an oven at 104 degrees Celsius for the duration of 24 hours. So the volume of water sample is 50 ml. Volume of water sample is 50 ml, and this 50 ml of water sample is kept in an oven at 104 degrees Celsius for the duration of 24 hours. During these 24 hours, all the water will evaporate, and when we take out this crucible, we are left with only solids. So once I take out this crucible, I am left with this empty crucible with these solids. So these are my total solids. So these are my total solids. Let me just change the color of this pen. So this is my total solids. Now the question further says that the crucible with the sample was dried to a constant mass of 61.89 grams. My dear students, this 61.89 grams is the weight of the crucible plus weight of the solids. So this weight of the crucible with the weight of solid, it is given as 61.89 grams. This is given as 61.89 grams. Further, the question says that the crucible with the dried sample was placed in the muffle furnace. We have already discussed that when we talk about muffle furnace, we are talking about just evaporating all the organic fraction of the solids which is present, right? So if any sample is placed in the muffle furnace, all the organic fraction of the solids will be evaporated and we are only left with the ash residue, right? So if I keep this oven dried sample of total solids in muffle furnace, if I keep this oven dried sample of total solids in muffle furnace. So this is my muffle furnace. In my muffle furnace, what is the temperature which is maintained at muffle furnace? Quickly, what is the temperature which is maintained at muffle furnace? Anybody? So the temperature maintained at muffle furnace will be 550 to 600 degrees Celsius. For 550 to 600 degrees Celsius for the duration of 2 hours, these solids are kept inside the muffle furnace. In the duration of 2 hours and at temperature of 550 to 600 degrees Celsius, all the volatile solids will going to evaporate, and we are only left with the fixed solids. So when we take out this crucible after 2 hours, we are left with only fixed solids. We are only left with the fixed solids, and the weight of these fixed solid along with the crucible is given as, the weight of these fixed solid along with the crucible is given as 60.02 grams. So this is given as 60.02 grams, right? In the question, it is asked that we need to calculate the organic fraction. We need to calculate the organic fraction of the solids that are present, right? So it's again a very easy question. If you understand the process, the question becomes very easy, right? So if you know all the process, this question is a very easy question. The only thing is you should keep a check on the process. So you have the empty weight of the crucible. So empty weight of the crucible is 58.68. Empty weight of the crucible is 58.68. Let me just add one more slide. So empty weight of the crucible, empty weight of crucible is 58.68 grams. Next, weight of crucible with solids, weight of crucible with solids, it is given as 61.89 grams. It is given as 61.89 grams. So weight of the solids, or the total solid concentration, will be equal to weight of the crucible with solid, that is 61.89 minus 58.68 divided by, now this amount of solids are present in 50 ml of the volume of water sample, right? So divide by 50 multiplied by 1000. Get me the concentration of total solids. Get me the quick concentration of total solids. Please get me the quick concentration of the total solids. Get me the quick concentration of total solids. Get me the quick concentration of total solids. Please calculate and tell me fast. The quick concentration of total solids. So this is 64.2 gram per liter. So this is my concentration of total solids, right? Next is my fixed solid concentration. My fixed solid concentration will be equal to the weight of the crucible with fixed solids. The weight of the crucible with fixed solids, that is 60.02. Weight of the crucible with fixed solids is 60.02. Good, good, good Prashant, good Rakesh, good Varsha, good Thirusar, good Kiran, everybody, all good. Moving on with this. So the total weight of the fixed with the crucible is 60.02. So this is 60.02 minus empty weight of the crucible, that is 58.68, and this amount of fixed solids are present in 50 ml of the sample. So divide by 50 multiplied by 1000 will going to give us the total amount of fixed solid. Give me the quick value of fixed solids. Give me the quick value of fixed solid. Okay, Rakesh, good. Give me the quick value of fixed solids. Jaldi se de do. Give me the quick value of fixed solids. Give it fast. Calculate and tell me fast. What is the value of fixed solids? Quick and fix are just confusing. It is 26.8. Good. It is 26.8 again, and this is in gram per liter. Now, if I have the total solid concentration and if I have the fixed solid concentration, can I calculate the organic solid concentration? Can I calculate the organic solid concentration? Good, good everyone. Good Hitesh, Karan, Varsha, Prashant, Thirusar, Rakesh. Okay, all well, all going good. all doing good, right? Just get me the quick value of organic solids. If you have the total solid concentration, you have fixed solid concentration, get me the value of organic solids. So the organic solid concentration, organic solid concentration will be equal to the total solid, that is 64.2, minus the fixed solid, that is 26.8. Get me this value quickly, get me this value. It is 64.2 minus 26.8. Get me this. It is 37.4. Correct. 37.4 gram per liter will be the value of organic solids. And what in the question we are asked? We are asked to calculate the percentage fraction of organic solid. If I need to calculate the percentage fraction of organic solid, just divide the concentration of organic solid by the total solid. So percentage fraction of organic solid. So percentage fraction of organic solid. Percentage fraction of organic solid is the concentration of organic solid divided by the concentration of total solids. Total solids, right? So the percentage fraction of organic solid. So organic solid is given as 37.4. This is 37.4, and total solid is 64.2. It is 64.2. It is 64.2. So what is the percentage fraction? Give me quickly. 600. How it is 600? We need to calculate the percentage fraction, not the percentage. It has to be in decimals. Please give me. It is not in percentage. Just give me the quick value of fraction. It is 0.5825. Is it? 0.5825. Okay, 0.5825. Correct. So it is 0.5825. Now I have intentionally introduced this question in this Gate Booster series. Why? Because in the question you are asked to calculate the organic fraction. And this organic fraction, until and unless not mentioned, has to be in decimals, right? If this type of numerical answer data type question comes, and for suppose after calculating the correct value, if you have entered the percentage, how many marks you might be getting? Not the negative marking, but at least a good 0 you will get. So please read the question carefully when you are attempting question of environmental engineering. They are very simple questions. They are very easy questions. The only thing you need to take care is take care of the units and read the question very properly to understand what is exactly asked in the question, right? So moving on with this is the question of total solids in which we have calculated the organic fraction and which comes out to be 0.5825. So 0.5825 is the correct answer. Everybody get that? Everybody got that answer. So it is good. Next question is, which of the following statement is or are correct? Please take care of this. It is a multiple select question. Okay, get me the value. Get me the answers. Please read the question and tell me the answers. It says that which of the following statement is or are correct? Which of the following statement is or are correct? Tell me the value. So first statement is turbidity is quantitatively related with the concentration of suspended solids. Yes or no? Option A is correct or incorrect? Option A is turbidity is quantitatively related with the concentration of suspended solid. Answer is correct. Option is correct or incorrect? Tell me fast. It is correct. So yes. Incorrect. So no. Tell me in yes or no whether this option is correct or incorrect. Turbidity is quantitatively related with the concentration of suspended solids. I have already told you turbidity is due to suspended solids. But can we say that if 30 milligram per liter of turbidity is there, then this much, if 30 milligram per liter of suspended solids are there, then this much amount of turbidity has to be there, right? Everybody is saying yes, yes. Naveen is saying no. Okay, both the answers I am getting, B and D, I got from Rakesh. Rakesh, tell me about option A. Is it correct or not? It is correct or not? Can you say this? Yes or no? Yes, Rakesh is saying yes, that it can be directly related with the suspended solids. Understand this very carefully. I am telling you one more time, right? When I talk about quantitative relation, when I talk about quantitative relations, I'm talking about that for X milligram per liter of concentration for parameter 1, there has to be Y milligram per liter concentration of parameter 2. Understanding this? Understanding this? Please tell me yes or no. Please tell me yes or no if you are understanding this. For X milligram per liter concentration of parameter 1, there has to be Y milligram per liter concentration of parameter 2. Okay, now understand this very carefully. This is something related quantitatively, correct? I have drawn an example in front of you. I have two water samples. In these two water samples, the same amount of suspended solid concentration is present. In both the samples, this is my sample number 1 and this is my sample number 2. In both these samples, same amount of suspended solid concentration is there, say 30 milligram per liter. Say 30 milligram per liter. In both the samples, same amount of concentration is there. Okay. Now tell me, if in the first sample my suspended solids are of this size, and in my second sample I have my suspended solids of larger size like this. In which sample you will have more turbidity? In which sample you will going to have more turbidity? 1 or 2? Or both the turbidity will be same? Tell me quickly, tell me, in which sample you will going to have more turbidity? In sample number 1 or sample number 2? Tell me quickly, in which sample you will going to have more turbidity? In sample number 1 or sample number 2? In sample number 1, yes, Hitesh, correct, Kiran, correct. Okay. So when I talking about more turbidity, I'm talking about how the particles are distributed. No doubt the concentration of the suspended solids in both the water sample are same. But for the water sample, having more finer particle and more distributed particle will going to absorb more light, will going to scatter more light. Hence, it will going to have more turbidity, right? So, no doubt, if the concentration of suspended solids are equal, then also the size of the particle will going to decide how much amount of turbidity is present in the water sample. So, here you can directly relate that this turbidity cannot be related quantitatively because same concentration of suspended solids may generate more amount of turbidity with respect to the other sample with depending upon the size of the particle. Is this clear? Is this clear? Tell me yes or no. Okay. Number of particles more turbidity. Yes, Rakesh. Yes, correct. So if the number of particles are more, number of particles are finer, more will be the turbidity, right? So turbidity cannot be quantitatively related with the suspended solids because if the size of the suspended solids is more, the water sample may have less amount of turbidity, correct? So option number A is incorrect. So option number A is, this one is incorrect. This one is incorrect. It cannot be related quantitatively, right? Moving on, true color is caused by suspended solids and dissolved solids. Tell me yes or no. Option number B, tell me about option number B. Is it correct or incorrect? Is it correct or incorrect? True color is caused by suspended solids and dissolved solids. Tell me yes or no. Tell me yes or no. Please tell me yes or no. True color is caused by the suspended solids or dissolved solids. Yes or no. It is caused by yes, no. Kiran is saying no. Rakesh is saying yes. No, Rakesh is not saying right now. So no, it is not. When we talk about true color, right? We talk about colors of water sample. If we talk about colors of water sample, so color of water sample is of two types. So color of water sample is of two types. First one is the true color. First one is the true color, and second one is the apparent color. Second one is the apparent color. Second one is the apparent color. Just 1 minute. Second one is the apparent color. When I talk about true color is only caused by, it is only caused by dissolved solids. It is only caused by dissolved solids. So true color is only caused by dissolved solids. On the other hand, apparent color is caused by suspended plus dissolved solids. Suspended plus dissolved solids, right? So hopefully this is also clear to you that true color is only caused by dissolved solids, and the apparent color is caused by both dissolved solids and suspended solids. Nice, good, Varsha, correct. Rakesh, yes. Okay, so option number B is also incorrect. This is also incorrect. The third one is the permissible limit of taste and odor is 1 TON. This we have seen just now in the permissible limit table, that the permissible limit of taste and odor is 1 threshold odor number. So option number C is correct. Option number C is correct. Next is water extracted underground water source is treated for both suspended and dissolved solids. My dear students, I have already told you that when any water is extracted from the underground source, it does not has any suspended solid. It only be treated for the dissolved solids. So water having or extracted from the underground water source is only treated for dissolved solids, and it is not treated for the suspended solids. So option number C is correct, right? So there can be question in your GATE exam, right, which are framed under multiple select question. But please keep this definition very clear. Multiple select question means more than one option can be correct. One option or more than one option can be correct. So this question can be a multiple select question having a single option C as the correct option. So option number C is correct for this, right? So answer key is option number C. So hopefully you are getting this. Shall we move on? Tell me yes or no. Tell me yes or no. Shall we move on? Okay, moving on with this. Next is our chemical water quality parameters. For chemical water quality parameters, we have dissolved solids again obtained by gravimetric technique. The permissible limit is 500 milligram per liter. Next is our alkalinity. My dear students, alkalinity is caused by the anions present in the medium. Alkalinity is the acid neutralizing capacity of water. So any anion means negatively charged particle. So if any negatively charged particle is present in the medium, it will going to cause alkalinity in the medium. Alkalinity is determined using titration, in which the titrant used is 0.02 normal H2SO4 and the indicator used is either phenolphthalein or methyl orange, right? The permissible limit of alkalinity in our water sample is 200 milligram per liter as CaCO3. The next one is pH, and pH is determined using potentiometer using calomel electrodes. My dear students, pH is a scale to measure the amount of H plus ions present in the medium. pH is negative logarithm of H plus ion concentration present in the medium. This pH is determined using potentiometer using calomel electrodes. I have already told you this. Calomel electrodes are only sensitive for H plus ions and OH minus ions. So the specific thing about calomel electrodes is they are only sensitive towards the H plus ion and the OH minus ion. So using calomel electrodes in the potentiometer, we can measure the pH of our water sample, and pH is nothing but the amount of H plus ions present in our water sample. The permissible limit for pH is 7 to 8.5. It is 7 to 8.5. The next parameter, chemical parameter, is the hardness, and hardness is the soap, the ability of the water to destroy the surfactant property of the soap. The form forming ability of the soap, how much amount of this form forming ability of the soap is destroyed, is termed as the hardness of the water. The hardness is again determined using titration, and the titrant used is 0.01 normal EDTA, and the indicators used are Erychrome black tea, right? The permissible limit of hardness is 200 milligram per liter. The permissible limit of hardness is 75 to 115 milligram per liter as CaCO3. It is as CaCO3. The next chemical water quality parameter is the chloride content. It is determined using titration technique, which is known as the Morse method. The titrant used is silver nitrate, and the indicator used is potassium chromate, right? So chloride is present in your water sample. That water can be either polluted from any sewage, or it can be polluted from any industrial pollutant. So if chloride content is present in your water sample, that water can be polluted either through sewage or any industrial pollutant. The most important thing is, please mark it as the most important thing of this last statement. It says that the minimum of total hardness and the alkalinity will be equal to the carbonate hardness. Wherever you are writing, just write it down and mark it as the most important concept. The minimum of total hardness and alkalinity will be equal to the carbonate hardness. Moving on with this, we have different chemical water quality parameter. Next one is the fluoride content. So fluoride is determined using color matching technique, and the color is developed using zirconium ion and alizarin. Permissible limit of fluoride is 1 to 1.5. 1 milligram per liter of fluoride is required for protection of our teeth. Whereas if this fluoride content exceeds 1.5 milligram per liter, same fluoride decolorizes our teeth and leads to a disease which is known as mottling of teeth. So the fluoride concentration has to be kept within 1 to 1.5 milligram per liter. That is the permissible limit of fluoride, right? Next is the nitrogen content. The nitrogen in your water sample can be there either in four forms. First one is the free ammonia, where the nitrogen is singly bonded to the other molecules, and it can be measured simply by boiling, and the amount of ammonia which is liberated is simply calculated. The second one is the organic ammonia, the nitrogen which is attached to carbon or which is attached to oxygen either through a double bond or a triple bond, which requires additional amount of oxidizing agent. This kind of nitrogen is known as the organic ammonia. When the nitrogen is doubly or triply bonded with any of the elements, it requires extra oxidizing agent, and this extra oxidizing agent is KMnO4. So when you boil the already boiled sample using this potassium permanganate, this potassium permanganate is a strong oxidizing agent, and it breaks the double and triple bond which was not broken earlier when the water sample was boiled. Then the amount of ammonia liberated once this oxidizing agent is introduced, and the total, and this again this water sample is boiled, then this ammonia is known as the organic ammonia. Next one is the nitrate. If nitrate is present in your water sample, it indicates that the decomposition of the organic matter is still ongoing in your water sample, right? So if the decomposition is ongoing, microorganisms will be carrying out the decomposition, and if such kind of water is consumed, the person consuming such kind of water will undergo waterborne diseases. So if nitrite is present in your water sample, means partial decomposition of the organic matter is happening inside this water sample, and if partial decomposition is happening, my dear students, microorganisms will be present in the water sample. If such kind of water is consumed, the person consuming this water will simply undergo waterborne diseases. So nitrite is determined using color matching technique, and color is developed using sulfonic acid and naphthamine. The last one is nitrate. Nitrate, my dear student, indicates the complete decomposition of the organic matter. When the organic matter is totally decomposed, it finally results into nitrate. So if nitrate is present in water, it indicates the complete decomposition of the organic matter. Nitrate is also determined using color matching technique, and the color is developed using the phenol disulfonic acid and potassium hydroxide. My dear students, the permissible limit of nitrate is 45 milligram per liter. Now I tell you this. If the nitrate concentration is more than 45 milligram per liter, and if this water is consumed by any newborn baby, right? If this water is consumed by any newborn baby, so this nitrate present in water, this nitrate present in water, if it exceeds 45 milligram per liter concentration, and if it is consumed by a newly born baby, so this nitrate is converted into nitrite, will be converted into nitrite by the special kind of acids, which are present in the intestine of, newly born babies, which are present in the intestine of the newly born babies. Now this nitrite has high affinity towards hemoglobin, which acts as an oxygen carrier in our body. In our body, hemoglobin acts as an oxygen carrier. So this hemoglobin, this nitrite, has high affinity towards hemoglobin, which acts as the oxygen carrier in our body. So this nitrite replaces oxygen in the hemoglobin, due to which the less deficiency or the deficiency of oxygen happens in a newly born baby, due to which it leads to a disease which is known as blue baby disease or methymoglobemia. Blue baby disease or methymoglobemia. So this blue baby disease is caused when the nitrate concentration is more than 45 milligram per liter, and such kind of water is consumed by the newly born babies, right? So these are the permissible limits of nitrogen. So for free ammonia, the permissible limit is 0.5 milligram per liter. For organic ammonia, it is 0.3 milligram per liter. For nitrite, it is 0 milligram per liter, because presence of nitrite indicates that the partial decomposition of organic matter is present, and because of this partial decomposition, microorganisms will be also present in the water sample. So this water need not to be consumed, because any person consuming this water containing nitrite will have waterborne diseases. And last one is the nitrate, which the permissible limit is 45 milligram per liter. I have already told you, if the permissible limit is more than if the nitrate concentration is more than 45 milligram per liter, it leads to blue baby disease if consumed by any infants or a newly born baby. Okay, moving on with this. So we have a question. It says that 170 milligram of HNO3 strong acid is added to water to bring the final volume of 1 liter. So in 1 liter of water, 70 milligram per liter of HNO3 is added, right? Further, the question says that consider the atomic weight of hydrogen, nitrogen and oxygen as 1 gram per mole, 14 gram per mole and 16 gram per mole. Calculate the pH of the water. Okay. So you are given with the concentration of HNO3 and you need to calculate the pH of the water. My dear students, pH is the H plus ion concentration. It is calculated through H plus ion concentration in moles per liter, right? So pH of our water sample is negative log to the base 10 of H plus ion concentration, and this H plus ion concentration has to be in moles per liter. It has to be in moles per liter, right? So if we know the number of moles of H plus ions present in the medium, we can simply calculate the pH of the water sample, correct? So in order to calculate the H plus ion concentration, I am given with the HNO3, right? The concentration of HNO3. I know that HNO3 dissociates into H plus ion plus NO3 minus ions, and from this dissociation one thing is very clear: 1 mole of HNO3 gives 1 mole of H plus ions, Is this clear, my weight? Is this clear? Is this clear to everyone? Please tell me yes or no. Is this clear to you? Is this dissociation very clear to you? What I am telling you, that HNO3 dissociates, HNO3 once added in water dissociates into H plus ions and NO3 minus ions, right? So if 1 mole of HNO3 is dissolved, it will going to lead to 1 mole of H plus ions, correct? So 1 mole of HNO3 will going to give us 1 mole of H plus ions. Now how to calculate the number of moles of HNO3? So the number of moles of HNO3, we know that the number of moles of HNO3 will be equal to the number of moles of H plus ions from this relation. So the number of moles of HNO3, number of moles of HNO3 will be equal to the given weight, divided by the molecular weight, So given weight is 170 milligram. Please take care, it is 170 milligram. So 10 raised to power minus 3, this will be in grams. And molecular weight is always in grams. And for HNO3, H is 1, nitrogen is 14, and oxygen is 16 into 3. So get me the number of moles of HNO3. Please get me the moles of HNO3, number of moles of HNO3. Using this, get me the number of moles of HNO3. Right. So this is 15 and this is 48. So this comes out to be 48 plus 15, it is 63. So the number of moles of HNO3 is 170 into 10 raised to power minus 3 divided by 63. So these are the number of moles of HNO3 present in our water sample. Now we know that 1 mole of HNO3 will going to give 1 mole of H plus ion. So 170 into 10 raised to power minus 3 divided by 63 moles of HNO3. 63 moles of HNO3 will going to give us same 170 into 10 raised to power minus 3 divided by 63 moles of H plus ions, right? And this entire concentration we are talking about is for 1 liter of water. So 2.69, good. Varsha, good. Just get me the value of pH. So we have the number of moles of H plus ions, and this number of moles of H plus ions are for 1 liter of water sample. So the pH of the water sample, is negative log to the base 10 of H plus ion concentration, that is 170 into 10 raised to power minus 3 divided by 63. So this is the pH of our water sample. Please get me the final value. Varsha, it is final value 2.69. Get me the final value. Of this. pH of the water sample, negative log to the base 10 of H plus ion concentration. Please take log to the base 10. It is not the natural log. It is 2.568. Good, Prashant, good. Correct answer. It is 2.568. So pH of the water sample is 2.568, and this can be approximated as 2.57. So this is the final value or the final pH. Yeah, correct. This is 2.568. Please take care of these minute things only, because in environmental engineering your question will only be incorrect if you ignore the details, if you take care of all the details, nobody can make your question incorrect, right? So please take care of all the details. So answer is 2.57. So for this question, option number C is correct. So everybody got this? Any doubt in this? Any doubt in this question to anyone? Any doubt to anyone in this question? Say yes or no. Any doubt to anyone? Any doubt, anyone, please? Yes or no? Yes or no? Say yes or no. Any doubt to anyone? Tell me yes or no. Okay. So shall I just move on? Okay. Chalo. So the next question is, the alkalinity and hardness of the water sample are 300 and 400 milligram per liter. Similar question is asked in GATE examination for 2 marks, right? Just understand the question and understand how easily you can secure 2 marks like this if you remember just a single statement that I said just a few moments back. Okay, the question says that the alkalinity and the hardness of the water sample are 300 milligram per liter and 400 milligram per liter as CaCO3. You need to calculate the concentration of carbonate hardness and the non-carbonate hardness of the water sample as CaCO3. How many have you understood this? It's one of the easiest question, and I must tell you this, somewhere down the line you will get this question for 2 marks, right? Just get this, right? You haven't got this, no problem. So we are given with the total alkalinity, we are given with the total hardness of the water sample. मैं लिख लेता हूं, let me write this first. I am given with the total alkalinity or alkalinity of the water sample. So alkalinity of the water sample is given as 300 milligram per liter. It is given as 300 milligram per liter, and the total hardness it is given as 400 milligram per liter, 400 milligram per liter as CaCO3 and as CaCO3, right? So this is the entire thing that is given to us. We need to calculate the carbonate hardness and the non-carbonate hardness. Okay. Now most of you might think like that, sir, this is a kind of a very complicated question. That is why it was asked for 2 marks. Okay. Let me just get you straight back, right? So let me just solve this question. Just remember, the minimum of total hardness and alkalinity is equal to the carbonate hardness. The minimum of alkalinity and total hardness is equal to carbonate hardness. So out of alkalinity and total hardness, what is the value of carbonate hardness? Anybody? What is the value of carbonate hardness? Good, Hitesh, good, Prashant, good, nice. So tell me the value of carbonate hardness. Tell me the value of carbonate hardness. If you have solved the question, no problem, it is okay, it is good. Tell me the value of carbonate hardness. The minimum of alkalinity should be equal to the carbonate hardness. Hello, Pranay, hello. Okay, Hitesh is saying 300, correct. So out of alkalinity and total hardness, the minimum of alkalinity and total hardness is carbonate hardness. So from here we know that out of these two values, 300 milligram per liter is the least value. So carbonate hardness is 300 milligram per liter. So this is 300 milligram per liter as CaCO3. So I have got the carbonate hardness as 300 milligram per liter. Good, Varsha, good. Carbonate hardness I have 300 milligram per liter. 300 milligram per liter as CaCO3. The next thing is, I know that total hardness is carbonate hardness plus non-carbonate hardness. So total hardness is given as 400 milligram per liter. Carbonate hardness is 300 milligram per liter. Non-carbonate hardness, please everybody tell me non-carbonate hardness is non-carbonate hardness is equal to 100 milligram per liter as CaCO3. Now please take care of the order in which the values are asked. The first value should be carbonate hardness and the second value should be non-carbonate hardness. So my dear Rakesh have made the same mistake. In just a lot of excitement, he did option number C. But carbonate hardness is 300 and non-carbonate hardness is 100. So option number D is correct. Is this okay? Is this clear? Everybody clear? Right? Is this clear? So one of the easiest question, if you remember this relation, then only this question is of 2 steps. Else, you don't have any other solution for this, right? So, okay, Rakesh, good. Please read the question carefully and please take care in which order the things are asked, right? So, first one has to be carbonate hardness and second one has to be the non-carbonate hardness, okay? So, this question is clear. Moving on. So, the next question says that the water sample contains following dissolved ions. We are given with the concentration of individual ions, right? We are given with the concentration of individual ions, not as CaCO3, just the concentration of individual ions. Is this clear? So the concentration of sodium is 60 milligram per liter, calcium is 50 milligram per liter, magnesium is 48 milligram per liter, and aluminium is 3 milligram per liter. Then we have concentration of HCO3 as 122 milligram per liter, Cl minus as 71 milligram per liter, and we are given with the atomic weights of all the entities that are present over here, right? We need to calculate the total hardness and we need to calculate the non-carbonate hardness, right? So first of all, tell me, if I ask you, tell me the elements that cause hardness in water. So you will going to tell me, sir, any multivalent cations will cause hardness in water. Multivalent cations, by multivalent cations, what I mean to say is all those cations which have more than +1 charge are known as multivalent cations. So multivalent cations are calcium, magnesium and aluminium. So all these multivalent cations will going to cause hardness in water. And all the anions will going to cause the alkalinity of in our water sample, right? So in order to calculate the total hardness or the total alkalinity, we need to calculate the number of gram equivalents of calcium, number of gram equivalents of magnesium, number of gram equivalents of aluminium, and we need to add it so that we can have total number of gram equivalents of total hardness, right? So what we have to do is, in this entire calculation, we are asked to calculate the total hardness and we are asked to calculate the non-carbonate hardness, right? So for this type of question, the only thing that you can do is first calculate the total hardness, that is the concentration of all the multivalent cations, all the multivalent cations, the concentration or the number of gram equivalents of all the multivalent cations you need to calculate. The next thing you need to do is, for calculating the carbonate hardness, you need to know the alkalinity. For alkalinity, calculate the number of gram equivalents of all the anions which are present in the medium. For calculating the alkalinity, calculate the number of gram equivalents of all the anions which are present in the medium, and for calculating the total hardness, calculate the number of gram equivalents of all the multivalent cations which are present in the medium, right? So moving on with this, then we can use the relation that the minimum of total hardness and alkalinity will be equal to the carbonate hardness. Once we know the carbonate hardness, we can very easily determine the non-carbonate hardness by just subtracting this carbonate hardness from this total hardness. Okay, so for calculating the total hardness, total hardness will be equal to number of gram equivalents of calcium, plus magnesium plus aluminium multiplied by the equivalent weight of CaCO3 multiplied by the equivalent weight of CaCO3. Two things I would like to clear. When number of gram equivalents you need to calculate, for calculating the number of gram equivalents, so number of gram equivalents is the given weight divided by the equivalent weight. If we are given with the weight of calcium, we need to divide it by the equivalent weight of calcium itself. Then only we will going to get the number of gram equivalents of calcium, right? If we talk about the equivalent weight, so equivalent weight is molecular weight. It is molecular weight divided by the valency. So just for your reference, I have written down how to calculate the molecular weight and the equivalent weight, right? So the total hardness is the number of gram equivalents of calcium, magnesium and aluminium multiplied by the equivalent weight of CaCO3. So the total hardness so the number of gram equivalents of calcium is equals to the concentration of calcium is 50 milligram per liter and the molecular weight of calcium is 40, right? So the given weight is 50 milligram per liter. So 50 into 10 raised to power minus 3 divided by molecular weight is 40 and the valency of calcium is 2. So equivalent weight will be 40 by 2, right? Next is for magnesium, the given weight is 48, I guess. The given weight is magnesium, the given weight is 48 and the molecular weight for magnesium is, the molecular weight for magnesium is 24. Again, the valency of magnesium is 2. So it is 48 milligram into 10 raised to power minus 3 divided by, it is 24 divided by 2 plus for aluminium it is given as aluminium, it is given as 3 and the molecular weight for aluminium is 27. So given weight is 3 and so given weight is 3 milligram per liter. So 3 into 10 raised to power minus 3 divided by 27 and the valency is 3 for aluminium multiplied by the equivalent weight of CaCO3, that is 100 by 2. So molecular weight of CaCO3 is 100 and valency of CaCO3 is 2. Therefore equivalent weight is 100 by 2. Get me the value of total hardness. Get me the value of total hardness in milligram per liter. Get me the value of total hardness in milligram per liter. Please get me the total hardness in milligram per liter. So this is 50 by 20, 50 divided by 20 plus 48 divided by 12, 48 divided by 12 plus we have 3 divided by 9. So 3 divided by 9 multiplied by 50. So we have 341.67. So this is 341.67 milligram per liter as CaCO3. So this is my total hardness. Similarly, my total alkalinity or alkalinity is number of gram equivalents of HCO3 minus ion plus Cl minus ion multiplied by the equivalent weight of multiplied by the equivalent weight of multiplied by the equivalent weight of CaCO3 multiplied by the equivalent weight of CaCO3. So what is the given weight of HCO3? I guess it is 122. So this is 122 milligram. So 122 into 10 raised to power minus 3 divided by 61 is the molecular weight, and valency of HCO3 is 1. Similarly, for Cl minus ion, it is 71 into 10 raised to power minus 3 divided by the molecular weight of chlorine, it is 35.5, and the valency of chlorine is 1, multiplied by the equivalent weight of CaCO3, that is 50, right? Get me the value of alkalinity. Get me the value of alkalinity. Quickly get me the value of alkalinity. So this is 2 plus 2, 4. 4 into 50. So 4 into 50. 200 milligram per liter as CaCO3. So this is 200 milligram per liter as CaCO3. So this is the alkalinity of the medium as CaCO3. So you have alkalinity, you have total hardness. You can very easily calculate the value of carbonate hardness present in the medium. So carbonate hardness is minimum of total hardness or alkalinity of the medium. So this carbonate hardness is equal to, out of all these two values, you will have alkalinity as the minimum, which is 200 milligram per liter. So your carbonate hardness is 200 milligram per liter. So your carbonate hardness is 200 milligram per liter as CaCO3. The next thing is your total hardness is equal to carbonate hardness plus non-carbonate hardness, right? So total hardness you have calculated as 341.67. So this is 341.67. So this is 341.67. Carbonate hardness is 200 and non-carbonate hardness can be calculated easily. So non-carbonate hardness is equals to 141.67 milligram per liter as CaCO3. So we have calculated the total hardness, we have calculated the non-carbonate hardness using the simple relation and the concentration of the ions which are given to us. Okay, so hopefully you are understanding this. Is this okay to everyone? Any doubt in this? Please tell me any doubt in this? Any doubt in this? Any doubt in this? Shall we move on? Any doubt in this? You are understanding this? Please give me yes or no if you are understanding this. Any doubt in this? Shall we continue? Okay, chalo. Now, next question says that for the chemical analysis of a water sample, following results were obtained. We are given with the concentration of C2H6. So the concentration of C2H6 is given as 20 milligram per liter. It is given as 20 milligram per liter. Next, the concentration of CO2 is given. So the concentration of CO2 is 5 milligram per liter. The concentration of CO2 is 5 milligram per liter. Then we have concentration of oxygen as 6 milligram per liter, ammonia as 100 milligram per liter. We need to calculate the total carbon content, right? We need to calculate the total carbon content in milligram per liter. Same kind of question appeared this year. The only difference is here I have asked for the carbon content. This year the question came for the nitrogen content. We are given with the two compounds along with their concentration, and you need to calculate the amount or the concentration of nitrogen present in the water sample. Now, when you get such kind of question, these questions are very easy to solve but a bit tricky to understand. Please take care of this, right? So when we deal with this such type of question, You first of all need to identify those compounds in which the required compound is present. For suppose in this question, you need to calculate the total carbon content. So first you need to identify those compounds in which carbon are present. So only two compounds are there. First one is C2H6 and the second compound is CO2. Only for which carbon is present, right? Now, it is very much clear that 1 mole of C2H6 contains 2 mole of carbon. Please say yes or no. Please say yes or no. 1 mole of C2H6 contains 2 moles of carbon. Please say yes or no. Are you getting this? Yes or no? Tell me yes or no. If you are getting this, tell me yes or no. 1 mole of C2H6 contains 2 moles of carbon. Please say yes. If you are getting this, tell me yes. If you are not getting, please tell me no. Say yes or no, then only I'll move, right? 1 mole of C2H6 contains 2 moles of carbon. Are you getting this? Okay, Prashant. Okay, thank you. So 1 mole of C2H6, 1 mole of C2H6 contains 2 moles of carbon. Contains 2 moles of carbon, right? So can you calculate the number of moles of C2H6? If you have the concentration of C2H6, you have the concentration of C2H6 as 20 milligram per liter. You have the given weight. You can have the molecular weight by multiplying 12 into 2 plus 1 into 6 and you will have the molecular weight. So accordingly, you can have the number of moles of C2H6. So the number of moles of C2H6 is the given weight, that is 20 milligram. So multiplied by 10 raised to power minus 3 divided by the molecular weight of C2H6, which is 12 into 2 plus 1 into 6. Please tell me yes or no if you are getting this or not. Rakesh, are you getting this or not? Please tell me yes or no. Have you got this or not? This is the given weight, that is 20 into 10 raised to power minus 3, and this is the molecular weight. Please tell me yes or no if you are getting this or not. Please. Okay. So this number of moles of C2H6 are there, and if 1 mole of C2H6 gives 2 moles of carbon, then this many moles of C2H6 will going to give twice the moles of carbon. Yes or no? Right. So this number of moles of C2H6, this number of moles of C2H6 will going to give twice the same number of moles, that is 20 into 10 raised to power minus 3, 20 into 10 raised to power minus 3 divided by, this is 24 plus 6, right? I have calculated directly. This is 24 plus 6 can be written as 30. These are the number of moles of carbon, the number of moles of carbon which are present through C2H6. Is this okay? So these are the number of moles of carbon which are present through C2H6. Similarly, when you look at CO2, 1 mole of CO2 contains 1 mole of carbon. Similarly, the number of moles of CO2 will going to give same number of moles of carbon. So 1 mole of CO2 contains 1 mole of carbon. So the number of moles of CO2 is the given weight. So the given weight of CO2 is 5 milligram per liter. So the given weight of CO2 is 5 milligram per liter. So this is 5 into 10 raised to power minus 3 divided by the given weight of CO2, that is 12 plus 16 into 2. So 12, 32 plus 12, 44. So this many moles of CO2, will going to give same number of moles of carbon, that is 5 into 10 raised to power minus 3 divided by 44 moles of carbon, right? So this many moles of carbon are due to CO2, and this many moles of carbon are due to C2H6. If I can have the total moles of carbon, I can calculate the concentration of carbon by simply multiplying it with the molecular weight of carbon. Is this clear? So the total moles of carbon total moles of carbon, total moles of carbon, total moles of carbon will be equal to the moles of carbon due to the moles of carbon due to C2H6, that is 2 into 20 into 10 raised power minus 3, that is 2 into 20 into 10 raised power minus 3 divided by 30 plus now number of moles of carbon due to CO2, that is 5 into 10 raised power minus 3 divided by 44. So these are the total number of moles of carbon that are present in the medium, right? So once we get the total number of moles of carbon that are present in the medium, simply multiplying it by the molecular weight of carbon will going to give us the concentration of carbon or carbon content. So carbon content is equal to number of moles of carbon, that is, this is 40 by 3, so 4 by 3 plus 5 by 44, I have taken 10 raised power minus 3 common, multiplied by the molecular weight of carbon, that is 12, and this will going to give me the concentration or the carbon content in gram per liter. So 10 raised power minus 3 in gram will be converted into milligram. Just get me the value of carbon content in milligram per liter. Tell me the value of carbon content in milligram per liter. Tell me the value of carbon content in milligram per liter. Get me the calculations. So the final value of carbon content that you will get. So carbon content get me the value of carbon content. Get me the value of carbon content. It is 7.36. Correct, Hitesh? It is 17.36. It is 17.36 milligram per liter. So this is the value of the carbon content that I will be getting in these two compounds. So when such type of questions are there, try to deal it with the number of moles. Once you have the number of moles of whatever entity asked, simply multiplied by the molecular weight will going to give you the concentration of that particular entity. Is this okay? So first of all, you need to identify that particular compound which is present in different compounds, right? So if you are asked to calculate the total carbon content, first of all identify those compounds in which carbon are present. If for same question you are asked to calculate the oxygen content, you have to identify those compounds in which oxygen are present and then calculate the number of moles, and then multiplying it with the molecular weight of oxygen, you can have the oxygen concentration or oxygen content of the compounds that are present in the water sample. Is this clear? So hopefully this kind of question you can deal very easily. This type of question was asked for 2 marks this year in GATE examination. So kind of an important question with respect to GATE preparation. So please take care of this question. Shall we move? Shall we continue? Okay. The next question is that a 400 ml sample of water has initial pH of 10 and 45 ml of 0.02 normal H2SO4 is required to titrate the sample to pH 4.5. Now, this question may seem difficult, right? If you don't know the process or what this question is conveying to you. If you don't know the process, obviously this question seems to be the difficult question ever happened to you, right? But if you know the process, this is one of the easiest question that you will going to face. In this entire description, you are given with the titration method for calculating the alkalinity of the soil medium. Water sample. You need to calculate, when you calculate the alkalinity of the water sample, what you do is, just 1 minute. So on the y-axis, I have plotted the pH. So this is my pH. And on the x-axis is my volume of acid used. It is my volume of acid used. This is my volume of acid used, right? I have started the titration from the pH of 10. I have started the titration from the pH of 10, and on adding acid, the pH of the water sample keeps on decreasing like this. At a pH of 4.5, so at a pH of 4.5, at this pH of 4.5, finally I got a color change, right? So in bringing down the pH to 4.5, the total volume of acid used is 45 ml, and the normality of this acid is 0.02 normal H2SO4, correct? You need to calculate the total alkalinity of the water sample. My dear students, alkalinity is because of the anions present in the medium, and alkalinity is the acid neutralizing capacity of the water, right? So if we calculate the alkalinity using this method, we need to equate the number of gram equivalents of acid used, and that will be equal to the number of gram equivalents of the alkalinity present in the medium. This question is a very simple question. It says that number of gram equivalents of acid used, this will be equal to the normality of acid multiplied by the volume of acid. So this is normality is 0.02 and volume of acid is 45 ml. Now my dear students, this much amount of acid is used to neutralize only 400 ml of sample. The volume of sample is 400 ml. So in order to calculate the concentration, divide by 400 and multiplied by 1000. So this is the total number of gram equivalents you will going to have for neutralizing 1 liter of water sample. So you have number of gram equivalents of acid used. This number of gram equivalents of acid used will be equal to the number of gram equivalents of the alkalinity. So number of gram equivalents of alkalinity will be equal to the number of gram equivalents of acid used, will be equal to the number of gram equivalents of acid used, that is equal to 0.02 into 45. This is 0.02 into 45, and this is in ml, so 10 raised to power minus 3 divided by 400 multiplied by 1000. Here I have just missed 10 raised to power minus 3. So this is again, here you have to add into 10 raised to power minus 3 because this one is in ml, right? So moving on with this. So this is the number of gram equivalents of total alkalinity present in the medium. Now the concentration or the alkalinity is the total number of gram equivalents multiplied by the equivalent weight of CaCO3. So alkalinity is 0.02 into 45 into 10 raised to power minus 3 divided by 400 multiplied by 1000 multiplied by 50. That is the equivalent weight of CaCO3. Just get me the quick value of alkalinity. So this alkalinity you will going to get in milligram per liter as CaCO3. So this alkalinity will be in gram per liter. That gram and 10 raised to power minus 3 will going to give you milligram per liter. Just give me the quick value of alkalinity in milligram per liter as CaCO3. Please give me the quick value of alkalinity as milligram per liter or as CaCO3. Please give me the value of alkalinity. Calculate it and tell me fast the value of alkalinity. So this is 112.5. Nice, good. So alkalinity is 112.5 milligram per liter as CaCO3. So this is my final answer with respect to the alkalinity of the water sample, right? So hopefully this question is also clear. Good, Varsha, good, Hitesh, good. Okay, moving on with this to the next question. Next question says that effluent from industry A has a pH of 4.5. Let me write this. So effluent from industry A. So this is for industry A and let this be for industry B. So for industry A, effluent for industry A has a pH of 4.5. So pH is 4.5. The effluent from industry B has double the hydroxyl ion concentration. The effluent from industry B, so OH minus ion concentration for industry B is twice of OH minus ion concentration for industry A. This is the relation you are given, right? You need to calculate the pH of the effluent from industry B. You need to calculate the pH of the effluent from industry B. Same kind of question was asked in GATE examination for 2 marks. One of the easiest question. The only thing you need to take care is you need to deal in the OH minus ion concentration, right? So if you are given with the pH of industry A, we can very well calculate that pH plus POH plus POH is equals to 14. So if pH is 4.5, POH is, tell me the value of POH for industry A. What is the value of POH for industry A? 9.5. So POH for industry A is 9.5. Tell me the value. It is 9.5. So POH for industry A is 9.5. Please cross check. Yeah, it's 9.5. So if I talk about industry A, my OH minus ion concentration. So what I say about POH. So POH for industry A. This is for industry A. It is negative log to the base 10 of OH minus ion concentration for industry A, right? So if my pH is 9.5, it is 9.5. So it is negative log to the base 10 of OH minus ion concentration for industry A. Get me the value of OH minus ion concentration for industry A. Get me the value of OH minus ion concentration for industry A. So OH minus ion concentration for industry A is 10 raised to power minus 9.5. So this is my OH minus ion concentration for industry A, right? Now we are given with the OH minus ion concentration for industry B is twice of OH minus ion concentration of industry A. So this is the OH minus ion concentration for industry B. So from here we have the OH minus ion concentration for industry B. So I can very easily calculate the POH for industry B. So POH for industry B is negative log to the base 10 of OH minus ion concentration for industry B, that is 2 into 10 raised to power minus 9.5. This is my OH minus ion concentration for industry B. Get me the POH for industry B. Quickly get me the value of POH for industry B. Quickly get me the value of POH for industry B. 9.198. Okay, 9.2. Rounded off, Hitesh. 9.198. Correct answer. Yeah, 9 is not. 9 is incorrect. So POH for industry B is 9.2. Let me just approximate. It is 9.2. So pH for industry B is 14 minus 9.2, and this could be 4.8, I guess. So pH for industry B is 4.8 is the final answer. So this is the pH for industry B, right? Getting this? Yeah, 9.198. Correct, Varsha, correct. Correct, Hitesh. So I have just approximated as 9.2, right? So when you just subtract it from 14, the answer you will get as 4.8. So 4.8 is the final value of pH for industry B. Correct? Moving on. Is this clear to everyone? Is this clear? Tell me yes or no. Is this clear to everyone? Is this clear? Is this clear? Shall we move on? Shall we move on? Yes or no? Tell me. Okay. Now talking about the next type of water quality parameter, biological water quality parameter. My dear students, when we talk about biological water quality parameters, we are talking about the disease causing microorganisms, right? And these disease causing microorganisms are termed as pathogens. But in actual, the calculation or the determination of these pathogens is a very tedious and a rigorous task, right? So what we do is, we want to calculate pathogens, the disease causing microorganisms. But we calculate coliforms. Coliforms are non-disease causing microorganisms. And these coliforms are calibrated with the colonies of pathogens. So by calculating the coliforms, we get the colonies of pathogens, right? We want pathogens, but we calculate coliforms. And these colonies of coliforms are related with the colonies, or I should say calibrated with the colonies of pathogens. Is this clear? So in biological water quality parameter, we go for the calculation of the pathogens through calculating the coliforms, and the colonies of these coliforms are calibrated with the colonies of pathogens. Is this okay? For determining these coliforms, we have this multiple tube test, which is known as MPN test. As I have already told you, in MPN test, 3 dilutions, 5 duplicates. 3 dilutions, 5 duplicates, total of 15 test tubes. Okay. So a question is there, a water sample is analyzed for coliform organism by multiple tube fermentation test. This multiple tube fermentation test is nothing but your MPN test. Further, the question says that for the sample dilution set of 0.01, 0.001 and 0.0001, the number of positive test tubes out of 5 were obtained as 4, 2 and 2. So these are the number of positive test tubes that we get, right? The most probable number of coliforms organisms for the above result is to be obtained using the following MPN index, right? So this is the MPN chart you are given, this is the calibration chart you are given, and this is the value that you have obtained through experimentation. This value you obtained through experimentation. Is this okay? So this value you obtained through experimentation, and using this value is obtained for these 3 dilutions: 0.01, 0.001, 0.0001. So corresponding to this dilution, these are the number of positive test tubes that you get. This is the MPN chart. You have to calculate the MPN of coliforms per 100 ml. So in this column, when there is MPN index, this index is prepared for 100 ml of the water sample. In order to deal for such type of question, these are one of the easiest question and still of the highest weighted question, right? The only thing that you need to take care is, first is just match the row of this positive test tube with this MPN chart. For the set of 422, just match in which row 422 is there. This is row number 1, this is 2, this is 3, this is 4. Tell me in which row the positive test tubes are 4, 2, Okay, is it audible now? Is it audible? You are not still audible. Okay, is it audible now? Okay, just this battery thing happened, right? So we'll just continue with this. So what I was saying is, when such kind of question is there, first mention, okay, so first mention, is this, just confirm me once more, is it audible? Just confirm me once more, is it audible? Okay, nice, chalo. So in such kind of question, you have to take care of first thing, that which row is matching with the number of positive test tubes, right? So we have 4 rows in our MPN index. This is the calibration chart that will be provided in the question itself. Rakesh, voice is not audible to you. Rakesh, just confirm it once again. Voice is not audible. Okay, now it's audible. Okay, chalo. Just match this number of positive test tubes, right? So we have this third row with the same number of positive test tubes, and corresponding to the third row, the value of NPN index that we are getting is 96 per 100 ml. But this 96 is not the final answer, okay? So when you deal with by reporting for this MPN value, so always report MPN value as MPN value per 100 ml per 100 ml. Just I have made this thumb rule for myself. This is not the standard formula, right? But it works everywhere. It is correct for everything, any type of question you had. Just observe this. So the value from MPN chart, multiplied by the first dilution in MPN chart divided by the first dilution of sample you prepared, multiplied by the first dilution of the sample you have prepared, right? So here you can see that the samples that we have prepared for analyzing is 0.01, 0.00001 and 0001, right? So this is my first dilution of the water sample that are prepared for testing, and this is my first dilution that is used for the MPN chart, right? So for MPN chart, the value used is 10. So this value, first dilution of MPN chart is 10. This is 10. And this value, the first dilution of the sample that we prepared, it is 0.01. Let me just check. It is 0.01. So the final answer that you will going to report is the value from the MPN chart is 96 multiplied by 10 divided by 0.01. So this is 2000. So this comes out to be 96,000. So 96,000 is my final value of the MPN per 100 ml of the sample. Is this question clear to everyone? Is this formula clear to everyone? Please write this formula, because this formula will going to help you and avoid all the confusion that comes when we solve the MPN questions, right? So this is again an easy question. This type of question is asked for 2 marks in the examination. So is this okay? Is this clear to everyone? Any doubt in this? Any doubt in this? Please tell me. Any doubt in this? Okay. Chalo, continuing with this. So we have covered all the water quality parameters. Once we have analyzed the water for its quality, then depending upon the existing quality of water and the desired quality of the treated water, we give treatment to water, right? The next topic of discussion will be treatment of water. The treatment of water is carried out either using screening, aeration, coagulation and flocculation, sedimentation, softening and disinfection, right? So one by one we will going to see all the treatment process that are given for treating the raw water sample. So first is the screening method. In the screening method, we know that screens are used to remove the coarse suspended solids from the medium. Okay, Rakesh, correct. It is the correct answer. Okay, moving on with this. So screens are used to remove the coarse suspended solids from the medium. Screens are always placed inclined in order to increase the effective surface area which is used for screening purpose. For example, if you have a depth of flow like this, for same depth of flow, if we have a depth of flow like this, if you place a screen like this vertically, on the other hand, if you place a screen like this inclined, so in inclined manner, the amount of area we will getting for same depth of flow will be more than the area that you might get if the screens are kept in a vertical position. So if more area is available, hence more will be the efficiency of screening. Hence the screens are always placed in the inclined position. The next one is coarse screens are used in the treatment plants, because if we use fine screens, these fine screens will going to get choked very frequently, which will require very frequent cleaning of these fine screens. No doubt fine screens will going to remove more number of fine suspended particles, but these fine screens will going to get choked in very recent times, right? It will going to choke very frequently. So in water treatment plant, we basically use coarse screens. When the water passes through these coarse screens or any screens, when the water passes through these screens, these bars or mesh present in the screens add friction over the flowing water. Due to this added friction of the screens over the flowing water, head loss occurs in the screen, and this head loss is measured using the relation as k by 2g v square minus u square, where u is the velocity of approach. If you have a screen like this, if you have a screen like this, for suppose this is your water, I am drawing the cross section and you have placed a screen like this, right? So the velocity with which water is approaching towards the screen, this is known as the velocity of approach u, and the velocity with which the water will pass through the screen is known as the velocity through the screen v, right? So head loss is k by 2g v square minus u square, where u is the velocity of approach, that is the velocity through which water is approaching towards the screen, and v is the velocity through the screen, that is the velocity through which water is flowing through the screens. Okay, as time increases, more particles will going to choke the screens. Due to choking of the screens, the available area for the water to flow through the screens will also going to decrease. If the area of flow will decrease, the velocity through the screens will going to increase over the period of time. So this v will going to increase, because due to choking the area of flow will going to reduce, but this velocity of approach, this will not be affected, this will remain constant, because at the constant velocity the water will be approaching towards the screen. But due to more choking, the velocity of flow through the screens will going to increase over the period of time. Due to this increased velocity, due to this increased value of v, the value of head loss will also going to increase. As you can see from the expression, if my v value will going to increase, obviously my head loss through the screens will also going to increase over the period of time. So if a question comes in the examination that out of two velocity, that is the velocity of approach or the velocity through the screens, which velocity will going to increase, so your answer should be the velocity through the screens will going to increase, because over the period of time more choking will happen, that will reduce the available area for flow. Is this clear? Correspondingly, your head loss will going to increase, right? So I have already told you regarding the screens. So screens are of two types, coarse screens and fine screens. In our water treatment plant, we use coarse screens. Please read the question and tell me the correct answer. Again, it is a multiple select question. Again, it is a multiple select question. It says that which of the following statement is or are correct? This is a multiple select question. This is a multiple select question. Which of the following statement is or are correct? First statement says that fine screens can remove finer size of particles. This is correct. Fine screens can remove fine size of particle. Hence are used for the treatment of community water. No doubt fine screens can remove finer particles, but due to removal of finer particle, these screens also clog for frequent number of times. Hence these screens are never used for treating community water. So option number A is incorrect. Option number B is core screens are also known as bar screens with a bar spacing of 20 to 100 mm center to center. So this statement is absolutely correct. For core screens, the spacing of bars that we used is 20 to 100 mm center to center. Next is the screens are always placed inclined in the flowing water, which helps in the effective cleaning of the screens. Exactly. So this option is also correct. Screens are always placed in an inclined order in order to increase the effective area available for screening mechanism, and also this inclined position helps in the effective cleaning of the screens. So option number C is correct. Head loss through the screen increases over the period of time. I have already told you, if the velocity through the screen will going to increase, your head loss will also going to increase over the period of time. So option number B, C and D are correct. Correct. Hitesh and Rakesh, correct. Very good, very good. Moving on with this, we have the next treatment process, which is known as aeration. My dear student, aeration is a mechanism in which water is brought in intimate contact with air, right? This intimate contact is developed in order to increase the dissolved oxygen concentration in the water. Oxygen is an oxidizing agent. Obviously, it will going to add oxygen. If you have the oxidizing agent, this oxidizing agent can very easily remove all the organic matter present in your water. This or dissolved oxygen, this oxidizing agent in the form of dissolved oxygen will going to oxidize all the organic matter which is present in the water, right? The next thing is, it will also going to oxidize the color causing compounds present in the water, right? So all the color causing compounds are removed through aeration. First thing is, aeration removes all the dissolved organic matter. Second is, aeration removes all the color causing compounds. The third one is, aeration removes all the other dissolved gases present in the medium, right? So when the aeration removes these color causing compounds, no doubt it removes the color causing compounds, but aeration increases the acidity of water. Aeration increases the acidity of water, right? Next is, it increases the acidity of water. The tray tower method is the most efficient method of aeration. We have 4 different methods of aeration. First is the spray nozzle method, second is the tray tower method, third one is the cascade aerator, and fourth one is the diffused aerator. Out of all these 4 methods, tray tower method is the most efficient method of aeration, but practically cascade aerator, being the less efficient method, is used in the water treatment plant. The sole reason being, for cascade aerator, there is no maintenance cost, there is hardly any operational cost. Hence, it proves to be more feasible when it comes to the operation point of view, right? So these cascade aerators are used in practical times for aerating this raw water. No doubt tray tower method is the most efficient method of aeration, but practically cascade aerators are used in treating this raw water. The spray nozzle method and for diffused air, additional cost is required for developing pressure. We need to send pressurized air, right, for spray nozzle method and for diffused aerator. So for sending these pressurized air or compressed air, additional cost is required. Hence these 2 treatment techniques for aeration are not used in our water treatment process. Moving on with this. So we have a question which says, which of the following statement is incorrect? Aeration removes the dissolved solids from the water. Obviously, aeration removes the dissolved solids. It removes all the organic solids which are present. It also oxidizes the inorganic solids which are present in water. Next is, aeration removes the suspended solids in water. No, aeration does not remove the suspended solids in water. The third option is aeration removes the color causing compounds like iron and manganese but decreases the acidity. No, my dear student, it increases the acidity. So this option is also incorrect. It increases the acidity, hence this option is also incorrect. So spray nozzle method is the most efficient method. No, it is not the most efficient method. So option number B, C and D are incorrect. So you have to mark option number B, C and D. It is again a multiple select question. It is again a multiple select question. So option number B, C and D. Good, Varsha, good. Good. So hopefully you have understood this. Hopefully you have understood this. Everything is clear to you till now. So we have covered up to the aeration method, right? In the tomorrow session, we will going to start with the sedimentation and we will finish the different methods of treatment of raw water. Then we will continue with the wastewater. And in the last moment of the session tomorrow, I will going to give you 4 numericals that will going to help you to identify which smart method you should pick, right? So hopefully this is clear for now. You have enjoyed the session, you have learned a lot of things, you have even revised a huge amount of syllabus in just a span of 3 hours, right? So if you have done this, that is the sole reason we have conducted this GATE Booster series. And my dear students, if you have developed this habit of revising your entire content through these questions, mark my words, nobody can stop you to get this rank of your desired choice, right? So revise your content for multiple number of times. Stay motivated, stay clear that you have always given your 8 months of your life dedicated to a single preparation, and you should have a very good rank in GATE examination to get a good PSU selection or get a good IIT for studying masters, right? So all the best from my side, my dear students. I will see you tomorrow, same time, 6 p.m. to 9 p.m. in the same channel, IMS GATE Academy. Thank you so much for listening patiently. Have a very good night. Thank you. Good night, everyone. Good night. Thank you. Good night. We're going to see you tomorrow. Okay, okay. Good night, everyone. Good night.